All right, guys, I think we're live now. Good morning, Berlin. Good morning, everyone on the live stream. We have a full lineup of talks today and speakers. It's going to be a more developer-focused day, AI-focused day, and AI tools. So before lunch today, we have myself presenting about Eliza plugins, and some cursor tips. After me is Martin from Coordination Network, and then we have Origin Trail, and Jay from Biard, who has another scientific agent project. So let's dive in. We are building on Agents on Eliza. It's a framework that has gotten popularity over the past, I'd say, since October, November, but it's been in development much longer than that. They have a new V2 version that's just about to leave beta, and our projects for the hackathon are already switched over to this beta branch, and we'll talk about some details of that today. And then everyone here, through learning about agents and through learning about Cursor, you actually can become an AI developer. Like, it's not that hard now. I think at the end of the talk, you might realize you could go home and start doing these things, even if you're not a traditional developer. So the Eliza Agent Framework is built on this diagram here. We're really just going to focus on the part of the top, the plugins, which extend the core part of the agent. Basically, the default agent has certain abilities to take certain actions, and how it interacts with the world is through plugins that developers write. And I'll show examples of that in a second. Some other things of note here, really just how the actions an agent takes, and we'll talk about this like action loop, and then the agent in this version can basically be part of different worlds, they call it, and there could be the same agent that basically is living across Discord, Telegram, GitHub issues, wherever you want it. It still has the ability to interact on all those spaces and still retains the same knowledge and memories. Here are just taken from the Eliza OS site. Right now, they have 176 packages, or like plugins live. Just you can see in the screenshot, they have GitHub, Solana agents, EVM, Discord, Telegram. There's a whole bunch of them. But what we've discovered is that really maybe the only scientific plugin that they have right now is for Origin Trail, which is a decentralized knowledge graph, which we're modified and using in our agents. But it's missing the ability to interact with the greater traditional scientific world. Maybe like Dataverse, it could basically interact with all these different tools and scientific plugins, like scientific backends. That could be different cloud labs. It could be virtual screening in silico. It can be maybe your lab has a special backend that it has, and so the agent just needs to have that API hooked up, and then it can interact with some experiment in your apparatus in your lab. But there's really no limit to what's possible and how to connect this. Think of it almost like Zapier or if this, then that. A few different things that help automate agents in the past. You can even get more versatility through plugins and then the actions it enables. More about Eliza, just kind of mental models. We have the agent runtime. We have the services that it can talk over. We have a database. And then for its behavior, we have actions, and then something called providers, where if it's about to take an action, maybe it's about to like either create an experiment plan or submit something to a knowledge graph, it can call a data provider to get more context. And then evaluators are a way to analyze past conversations, or basically it's general thinking to get extra insight into, so you could have maybe like an evaluator that could be a special like scientific model. Maybe like I talked about yesterday, something called like TX-Gemma, which is like a therapeutic drug discovery model. And so you could set this up to be run an evaluation step where that specific model is used for it. And then there's the kind of typical now, like a RAG system for knowledge. RAG stands for Retrieval Augmented Generation. And so this is a way to basically add to and extend what an agent knows about. A few more. Some of these are new in this new version of Eliza. Something called worlds, which is the context and the structure of how the agent is managing who it's talking to. And then within that, you have rooms, which are spaces for conversation, kind of like it could be a Discord channel, it can be a Telegram room. So there's a few things there. And then entities are just an abstraction for kind of like helping it understand the knowledge and the context of who it's talking to. And then the last ones to mention here are tasks, which are kind of similar to like Redis, if you've used that. It's pretty bare bones right now, in a way. So we're working on ways to basically automate these tasks that are running. And so, as I explained, like the multi-step processing, where there's different discrete knowledge tasks attached to like basically the scientific method. We're setting up for these agents to run through multiple tasks, sometimes in a loop, sometimes extending, like going on to the next task. And so that's it. And then lastly, plugins here are what I just talked about, and so they're a big part of these agents. The Eliza, the continuous cycle of Eliza is providers gather context before the response is generated. Then the agent has a set of actions it can take. Some are default actions in the core of Eliza, and then importantly, the plugins it has access to, the plugins that are enabled, give it more actions available for it to take. So maybe it didn't know how to interact with GitHub, and then you just switch on. Super simple to switch on the GitHub plugin, and then all of a sudden it can interact with the GitHub issues and both read and write from GitHub. I'm going to maybe skip through the rest of the slide. It's just, it's kind of self-explanatory. There's entities and components for knowledge and who it's talking to. The changes in V2 for Eliza, just as a note, if the main branch of Eliza is still on V1, they're about to have an official release in the coming days to weeks, but we already have the BioAgent and the BioAgent plugin working on the V2 branch. So I'd ask that basically hackers who fork it, you'll already be using this, and so you won't need to do anything. And then if you're not forking our code, then you kind of have a choice. You'll hear later another workshop from Eliza, and we can talk about that in the Discord, and if you'd like help. And for anyone who's not a developer here, this is actually something that is very approachable, and you could get started. This is basically talking through the documentation that I'm going over. And for developers, you'll find in our own documentation for the hackathon, we've followed this setup here. Basically, the key things to look at in the code are the agent runtime, so just a default project structure that you should follow. The actions and providers are how the agent takes actions in the world. Services are where it's talking, and then plugins are the main thing that we think it's easiest to get started with, where if you have an interest, basically anything that you're an expert in, anything that you're working with day to day, you can write a plugin. Just basically, you fork the existing plugin, and you'll see a few steps to kind of talk to an API, or basically, talking to an API is the simplest way. And then based on the structure of the API, you set up different actions that the agent can take, and that's pretty much it. So these Eliza, so BioAgents have a unified plugin architecture where everything is a plugin. That's clients, adapters, actions, evaluators, and services. Like every single thing is a plugin. And so that's, just the different list here All of these are in scope for the hackathon. You can basically modify the existing BioAgents or core agents with any of these. And yeah, so any of your ideas, any of your ways to interact with the traditional scientific world, TradSci, like Web2 scientific API endpoints, all these can be implemented. Yeah. Just a few more code details. This is like the plugin interface. You have a way to submit a PR into something called the Eliza OS registry, and then your plugin will just be basically a separate repository inside of the Eliza plugins organization. And this is nice because it allows you to set up separate CI/CD pipelines, and also for a developer, it's really just a binary. You can look at the list of plugins, and then it's just a Boolean to flip them on or off. And through that, yeah, we expect kind of like almost cookbooks to be created and like recipes for how, because there is a approximate limit on how many tools an agent can have access to. So if you have a list of actions an agent can take, it's basically just a big JSON file where it says like, this is the name of the tool, this is what it does. And so as the agent is thinking, it has some task that it's trying to do, and then it chooses which tool to call from that list of actions. And like anecdotally, and it's been basically around 100, 150 is the limit of how many actions an agent can basically reason through without having more false positives or false negatives as far as like missing an action or taking the wrong action. And so that's kind of gives you an approximate limit to how to encapsulate the agent and how much complexity you can create into the agents around. Shooting to keep it to around 50 actions it can take is probably more than sufficient for the agents right now. Here's just a slide about the plugin structure. Again, this is straight from the Eliza OS registry GitHub, so you'll find this there. And just one note about how plugins are loaded. They're loaded dynamically at runtime, and so there's a few cool things you can do with kind of variables inside the plugins to read from the local environment. It can read from, maybe it's loaded, you run it with some access to some proprietary data, the plugin can load that in. For our own plugin, this is something that we're encouraging hackers to fork. You can either use this or fork it. And we've created a way that we continuously modify, we monitor a Google Drive folder for new scientific documents. When it detects something new, it automatically transforms those papers into a structured knowledge asset and incorporates them into a knowledge graph. There's basically 3 steps to it. There's ingesting papers, adding them to knowledge graph, and then traversing the knowledge graph to generate hypotheses. So this plugin handles all 3 of those steps. It shows you how to watch a data source. It shows you how to analyze a paper in that data source to add it to a knowledge graph. And then it shows you how to traverse the knowledge graph and try to basically force an insight out of an agent. You ask it to, I mean, just like prompting, you ask it a question, we set it up to force the agent to continuously look at the keywords and assets inside of a knowledge graph and just try to think, kind of like a human does. Like if you have an access to knowledge graph, you try to think about next steps, you try to think about connections between things that are not clear, and this is how hypotheses are generated. And lastly, we've implemented a scoring rubric where every hypothesis that's created from an agent is judged by a simply called a judge LLM that has the ability to obviously do some web search and has a rubric for how to do it. Right now, the rubric is very tied to a specific domain around longevity. And so we'll be extending that to more domains, and it's in scope for the hackathon to really improve the benchmarking and the rubric that the judge LLM works with. All these are inside of our GitHub. The three main repos are the plugin BioAgent, the BioAgents, and CoreAgent. And the repo is bio-xyz on GitHub. Then I just wanted to wrap up with some cursor tips. Maybe for the room here, who has used, there'll be two different questions. Who has used either like Lovable or Bolt for kind of a design work for AI? We've got a third of the room. And who has used like Cursor or Windsurf for code editing? A lot of the same people, maybe half the room. Cool. These are some tips that I've found. Let me see if you guys it's probably easier to see this on the live stream than here. But this is just what Cursor looks like when you use it. You have the code on the left, and then you have the chat on the right. And previously, this is actually, Cursor is a fork of Visual Studio Code, which was made by Microsoft, and it's very common. Just use it for the past decades for code development. And the unique thing that Cursor, the company, added was a agent chat. Well, first it was just a chat, and then they have now agent mode. So yeah, so it has access and knowledge about your code base. And what is just extremely new, it's why Cursor is so used right now, so popular and so prevalent, is that this kind of changes how people code. Like before, it was a lot harder to code fast, and so now you hear about like vibe coding, but there's also experienced developers can also use Cursor to accelerate and both plan. There's something in coding called like rubber ducking something, where you have just like a rubber duck and you talk to it. And before agents and before like the past years of AI, it would just help you kind of formulate your thoughts, formulate your plan. And now, when you use Cursor in chat mode, it's like that, but of course, many times smarter than a rubber duck. And if you use it in agent mode, it is able to change files, it's able to create files, it's able to fix bugs in your code base, it's able to yeah, pretty much do anything at all. And so people are using it to, you can clone, you can download our repository, you can ask the agent to look at it, and you can ask it in plain English, like, I'm an expert in this field of biology, this is what my lab stack looks like, this is what I do day to day. Do you have any ideas for plugins? Do you know how to implement a plugin, how to do all these things? And so you can just chat with it, and you might find it surprising how helpful it is and how it lets you get something working on hour one or day one of this process, which before it would either take a code developer weeks to do the same, or for non-developers it would be impossible. But now I encourage you to think it's within reach. A few more tips is that there's something called user rules and project rules, and these are very necessary to use because the baseline agent that you work with doesn't have any context about either what you're trying to build, or in general, there's extra rules that you can add that show it. And so these are examples of, like, I just took this as a screenshot from what I use. This is like working with Next.js, both backend and front end. And so you might think that they're kind of verbose, like it's longer than you would think, but this is helpful. It's been proven, and you can find that we've shared this in our documentation, but you can also find people. Again, it's a little bit more art than science right now, and so there's actually new websites that are just talking about Cursor rules and sharing them for different, either different programming languages, different tasks, and it's super important to use these. And you can also have projects, these are global rules, and you can also have project-specific rules, which are helpful. Another thing is documentation. You can just add new docs. If you're using a doc site regularly, you just paste the URL, and it's going to traverse basically the documentation tree and add in all the documentation. And this is again, just like giving it, this is kind of like RAG, where you're teaching your agent about like the code that you're working with, the documentation, and this is a necessary step for sure. There's something between called chat mode and agent mode, and then for the models themselves, there's something you can enable called thinking. And I have an example here. Actually, go back. So when you use chat mode, it's not going to change any code. And when you use agent mode, it does. And that sounds simple, but you want to, especially the recent versions of, so Claude Sonnet 3.7 is the name of the model that's currently, for all intents and purposes, it's basically the best model for coding. And it has a tendency to change extra parts of the code, maybe adding in comments, adding in things that you didn't explicitly ask for. And so you have to use chat mode first to talk to it and plan out what you want to build, and then use agent mode to code. And when, I'll share the UI now. So this, so this is like the main UI. So there's a few things that are doing a lot of work here. There's the context, there's the agent versus chat in the bottom left, and then there's the model where it says Claude 3.7 Sonnet. And so each of these has important things to know about. For context, just like kind of adding documentation helps it in general. If you want it to really focus in on a specific part of the documentation or part of the code or part of your file structure, you use the context for that. You just like, kind of like mentioning something on Twitter, you just @ and then you complete what you want it to focus on. And you can add in many different things. You can add in 20 different files. Just basically can explicitly tell it what you want it to care about for that specific question. In the middle, you have the selection between agent and ask. This is basically agent mode or ask mode. In general, you want it to be in agent mode pretty much all the time. But sometimes you can use ask if you're just, that's like the more traditional, like kind of ChatGPT and asking it. When it's in agent mode, it's able to change files and add files, delete files, change the code. And there's a few different settings whether you want, I personally recommend it. The default mode is you have to accept every single change. And so, yeah, it's good to just know what, it's both helpful for stopping it from doing the wrong things, but also helpful for just keeping some context on what is changing. For my own context on what is changing, it's helpful. The last thing to note here is this, on the right, there's a button to click called Thinking, where you can turn it on or off. And I recommend always using Claude 3.7 Sonnet, which is the model there. And when it's in thinking mode, it's going to take basically extra time to analyze its own responses. And so when you're asking it to plan, it's good to have it on thinking. But when you're asking it to implement code changes, it's better to not have it on thinking because it's slightly, the code is slightly improved when it's off. And the last thing I'll have an example of is the problem framing, where you should always start by saying, I just want to discuss this without writing any code. And that really puts it in the mode of just thinking and planning about what files to change and what methods to modify. And then once you read through and see what's about to change, then you say, OK, implement the plan. And it's just going to boom, boom, boom. It can do like 50 different changes and implement all of it. The other thing to note is part of the planning is that you can have either just running it on localhost, or you can ask it to implement a easy-to-check plan, like basically a test plan, for when it does do the changes, how to ensure it's actually working. And here's the last example today is just on the left side, I said, write an overview of the files to change in core to do these steps. And so that's basically in a directory called core. And there's more than just 3 steps here, but it came out like 7 steps of all the different things to change. and these were all correct. And yeah, basically there's not a lot of trust that you can put in these agents because this in total was maybe 20 different changes to the file base, 100 lines of code change, and there's no errors there. And on the right side of the screen, you just see like, basically how it's able to change the code. And then hopefully, as it finishes a run, or like as it finishes a set of changes, it will explain what it did and share with you. And you can either read it, you can also just copy paste these changes into a file, which basically it's called like a .md file, and you keep track. It's helpful to keep track in case if something does go wrong. There's ways to restore a checkpoint where you just go back and like the code is reverted. You can also save these in order to, again, like basically you can save this in Notion, you can save it elsewhere, and then you have a list of changes that the agent made. And so if it ever is acting a little weird, if it's like stuck in something incorrect, you can just paste back in the previous changes it did, and that just helps it get back on track. I think that pretty much wraps up my talk today. You're going to have, later in the afternoon, another talk from Eliza, from the Eliza team. We just went over how to build an agent and what's the core things to think about when building agents, and then cursor tips. So if for any non-developers here, or for anyone just in general, if you download Cursor and then you download the BioAgent repo, and then you ask Cursor about the BioAgent repo, you're really close to, I can help you today and like throughout the hackathon, everyone's here to help, but like that's just by using Cursor and forking our code, you can be very close to doing something unique and something new related to your field of work. And so we have we're calling like a 2-week plugin sprint for the hackathon, where we have $10,000 US available to the teams that complete plugins in the very start of the hackathon. The hackathon itself started yesterday and runs through June 8th. So it's about 2 months long, and we want people to build plugins in this first 2 weeks because what people build now are going to be used for scientific outputs later in the hackathon. The greater, basically the scientific world, there's the crypto AI world and the Web2 AI agent world, and right now there's not too many projects trying to bridge the gap. And one of the problems with, as I said in the beginning, the biggest problem is that there's scientific plugins missing. We think there's a lot of low-hanging fruit for connecting the bioagents to traditional science and data sources. So there's lots to build. We're here to chat, and if you have ideas, we'd love to hear them, and then we have ideas for plugins to build as well. So thank you for listening.
All right, do we have any questions? I see one from Slava.
So, yeah, thanks. Great talk. I have a question about knowledge graphs. You know, I'm working with knowledge graphs, and I know a little bit difficulties. So, what kind of triple store you will recommend to work with knowledge graphs, and how you are handling updates in knowledge graphs?
So we have 2 different ways of working with knowledge graphs. The BioAgent plugin itself has a way to set up something called OxyGraph, which is based on it's called the Spark QL knowledge graph framework. We also integrate with Origin Trail, which is a decentralized knowledge graph. And so they have slightly different ways of constructing a knowledge asset. But when we analyze a paper, we go through it and look for all the different entities and create triples from those entities. And something called, for biology, there's something called ontologies. And so we attach them to ontologies and then add them to the graph. And that's the quick summary. There's yeah, there's a lot of details that go into this.
Yes. So what will happen if triples will change or will be wrong? How you will handle this?
We can either modify the graph with the change triple as well as depends whether like your source of authority changing the triple or marking something as incorrect or
Relationships being predicted incorrectly.
Yeah, and when we're setting up these bioagents, we want them to be run in a distributed fashion, and so they're running. Basically, we're writing the code that they're running, and so we have some way to ensure that what the distributed nodes, like distributed agents, are doing is correct. And so we would basically take the updated information as the more recent information should be treated with precedence, like treated as correct, in the sense it's always possible to re-overwrite something.
So you are overwriting. Now, this is really theoretical question, because if I'm thinking about the blockchain, this information about wrong links, wrong relationships, should be also available for the model, not to make the same mistake next time.
Well, it's almost, I think I have to look at it exactly, and again, this is can change. This is for the past few months of development. It's in flux, but it's almost like a stack. Like each node in the knowledge graph can be like a stack where the previous things are not overwritten, but the one on the most recent change takes precedence, or like people can look at the changes over time. But in theory, because we're trusting the modifiers of the graph, something that's more recent could be viewed as the best.
Okay, thank you.
And just to add a little bit onto that, we also are big fans of Neo4j. So if there's anyone out there who prefers that to Oxygraph as their knowledge graph of choice, we're a huge fan. And Slava, we are having a presentation from the Origin Trail team later today, so that could be another great resource to ask. Hadar? No? Okay.
So I have a Eliza question. I'm interested in fine-tuning. Is it possible to take like a local model, then set up like a LoRa adapter and like do some reinforcement learning for the agents?
Yeah, let me go all the way back through the presentation to the beginning. So like 100% yes, but the Eliza framework is almost where would it be? I guess just like in the agent runtime, it's choosing which model to use. That could be GPT-4o, like basically Anthropic. It has an API endpoint that it's calling to get the inference. And so if you have a fine-tuned model, that could be through your own like custom OpenAI model, you would change the URL that the agent talks to. And so the fine-tuning is separate from the agent framework. You just basically point it to your fine-tuned URL, and it would...
Yeah. So like the use case I'm thinking about is if I have a judge that kind of like tells me, oh, the agent did like a good job or not, and then kind of like fine-tune the model based on the agent behavior. So I would be interested in actually like fine-tuning it in the agent framework.
Yeah, and so like the judge, kind of the idea of a judge or like a filter LLM would be that could be either more expensive or have some proprietary data source that helps it. If you have the same AI that creates a hypothesis and judges it, it's kind of you want the judge to have more knowledge, more skill, more intelligence in judging than even the creation. Which seems to make sense to me. So the judge could have a separate, like the fine-tuned inference endpoint.
Yeah, thank you.
All righty, last question.
Hi, it was a really nice talk, but I have a question related to BioAgent and how it works with Eliza. So I have a local setup of BioAgent. I want to understand, like, when you are passing a query to BioAgent, does it pass the query to ChatGPT or Anthropic to get the response, or it does some literature review, summarize the literature, and give the response? Because what I got is basically a small summary based on my query. I want to better understand the flow, how it works.
We're using GPT-4o for most of it right now. We see an easy thing to add ourselves, and like the models we talked about, like if there is a question about a specific scientific domain, like one of the things in the hackathon, and I mean our own development, we need to give it access to like different models. Like we don't currently have something like OpenRouter set up. I mean, we could point it at OpenRouter, which is a way of changing which model is used based on the query itself. But yeah, something to really want to see explored in the hackathon is using scientific models in the plugins it uses, and see, it can give it, I think, a lot better either at judging or like any different task that's related to a very specific scientific, like a field of science or discipline. Like we don't, it's possible to do that, but we're not doing it yet. It's just like GPT-4o for the most part. Cool. So let me introduce the next speaker. Martin from Coordination Network has something really cool to see, and excited for it.
Okay, perfect. Just wait for the slides to appear. There we go. Okay, good morning, everyone. Thank you for joining today. So what I'm going to be talking about is how can you give agents human expert verified skills. Now, the reason I'm going to talk about that is because in science, the quality of your output is quite important, especially because if you're developing something and you're not an expert in the domain, LLMs can easily trick you. So what we want to help create is the ability to create workflows, agentic workflows, and have them verified by scientists so that you can trust that output, essentially, as you start chaining it together. Because you can imagine at scale, if these agents start having slightly erroneous outputs that aren't then checked, the whole society can go in a rather unfortunate direction. So how do you give agents expert verified scientific skills? Now, a key point here is that within different domains, the people who have the knowledge to verify this often have a limited time. So you want to create an experience that makes it easy for scientists to take part and give input into how your agents are performing. Now, to give you a context of how we've approached this, I'll first start by talking a little bit about where we're coming from. So about 3 years ago, just about 3 years ago, when we saw the convergence of what's happening with the latest AI capabilities, this was a bit before the ChatGPT release, when we started looking at this, and within what was possible with programmatic incentives, what was being talked about in DeSci, and the opportunity in science, we saw that creating an open source environment for bringing together experts and having it be possible for them to provide their skills in such an ecosystem would be very powerful. So over the past 3 years, we've been mapping essentially what are different steps in this process of going from an idea to an outcome in the sciences and talking to scientists about how they try to solve this. And it's been a journey of really prototyping and understanding relative to the latest capabilities of LLMs, how far can they take us and what do we need to do in order to create an experience for scientists to contribute to. So we're very honored where, DeSci has really enabled us to do this on an unprecedented level because of the transparency and the values of, for example, the BioDAO. So, many of you in this room have been giving us input in different stages of this journey, and it's really been essential for us to be able to validate rapidly that we're actually going in the right direction. And what's exciting now is that we've also been working with more traditional organizations, and just to speak to the BioAgent opportunity, there's a realization in the broader scientific community now that the way things have been done in the past need to change. We also work with funders of science, and there's an increasing understanding that there's a need to set new funding mechanisms that can be run programmatically, and where agentic scientific swarms can play a really important role. So I think the world is now catching up in a sense with a lot of these pieces, so it's a great time to be building in the space. And so as a result of this, we are now in a position where we have an open source platform that lets you rapidly create these skills. Through the creation of that platform, we have already then catalyzed a multidisciplinary expert network. And we're now moving towards the next step of how you can layer a programmatic incentive system on top of this so that you can actually reward people for their contribution. Because any scientist in the room might know, some scientists are somewhat skeptical about giving over all their expertise to these automated systems. So we want to create an ecosystem where people are rewarded for doing so. And that's really one of the key things that we've been driving towards. As a side note, this is where we think a lot of the discourse around retroactive public goods funding is very exciting here. Deep funding is an initiative that I would check out that is currently focused on open source, but is now being extended to research. And these are the types of capabilities that will enable not just the experience of providing skills in this way, but also reward mechanisms. So let me just kind of dive into what do these skills look like. If any of you have used a kind of visual LLM coding flow, it might look familiar. But essentially, it lets you construct these pipelines and allow you to have a certain level of determinism on top of these probabilistic systems. Now, if you're not familiar with those terms, the key thing to keep in mind, LLMs, if you give them something, they will give you different types of output each time. So what we're trying to find is how do you balance the benefits of that in terms of the power of these systems with then needing some sort of consistency when you're running these. So the way that we typically set this up is that you'll have an input point, and this will go into a prompt with some guidance on how to handle that input. This will give you a response. And you can then extend this in multiple different ways. For example, you could send that response to an external evaluation agent. Any of you building agentic systems here, you can build integrations into these as well. I can speak to that further later, or if you have any questions, let me know. But you can also have human evaluation steps. So basically sending this out for human evaluation and then getting context back that then goes into a refinement step. And then you get the finalized response, and this is given to an output. Now, this is a very simple example, but the core thing that I want to speak to the developers in the room is that basically you have an input and an output, and these become your endpoints that you can use as a tool call for your agents, essentially. Now, another important point is that with these skills, they're basically versioned so that every time they're running, you know what skill you ran and the output for that. So you build up also an interesting benchmarking database, basically, for that verification of how well it's performing. So that's just the kind of skill structure in a nutshell. So now I want to show you what this actually looks like in practice. So if you log into the platform, you basically come in, you have a profile, and you can create your skills. These look like cards. And what I just showed you behind this, you basically have one of these flows with an input and an output. And these are very versatile, essentially. So I'll show you an abstract analysis skill. So this was done for a test run for a prominent foundation that's working on Parkinson's disease. And essentially, it's a skill to evaluate abstracts as to whether they should be used for deeper dive analysis in terms of identifying relevant literature for a specific gene type in scientific research to cure Parkinson's. And so you set up the skill, as I showed you, and then you can run it. And on I quite like this visualization, because here you see all these inputs that it's now going to be analyzing, and then it will run this for you, and it's generating a table, essentially. So this gives you a way to set up an environment where if you're feeding in some abstracts or literature that you want analyzed, and you want the output to be, for example, in a tabular format, this gives you a way to do that. And everything is in Markdown, so you can actually present that to your, your collaborator scientists for verification and so on. And once you're done, you basically have your output. And just as an example here, as it's in Markdown, you can literally copy and paste that if you so wish, and put it into something like Google Sheets to share. So it's really like, there's a lot of pragmatism in this, where you're basically setting up ways to run these flows, get output, evaluate it, and be able to refine it that way. Again, as there's a lot of developers in the room, you don't need to plug it into Google Sheets. It can be an API call to get that and put it wherever you want it, or pass it on to your agent for further consideration in whatever pipelines you have available. Another example is then, so with the abstracts that I showed you, that was a first step to evaluate should that abstract actually be analyzed deeper. And so this is just an example that then you could take those, the kind of, once you get a yes/no on whether you want to go further with that abstract, that can be handed off to a deep dive analysis, and then a similar type of structure can be done, but answering different, more specific questions where you know that you want to analyze the full text of those papers. And again, it will generate a output. And here it's a little bit compressed, but as you can see, again, easy to copy out. And now it's done a deep dive analysis of those papers and the particular details that were relevant. And so this gives you a way to kind of get a sense of how it brings what is happening, let's say, often behind the scenes in the coding environment and so on. It gives you a way to kind of bring scientists into that universe without necessarily needing to onboard them into too much complex new technologies, essentially. And we've seen this resonates very strongly. Now, what I want to show you next is going a little bit, let's say, more creative, where the other thing that we've been working on is we collaborated with the Foresight Institute, which is a great nonprofit based in SF that brings together communities around frontier technology. They have an initiative called Tech Trees, which is around mapping pathways to solving complex problems, often within things like neurotech, longevity. Those are two of their focus areas, also molecular machines. And so what we worked with them on is how can you actually automate the creation of these roadmaps that then could allow for an environment to get human feedback on what are the right pathways, and those could then initiate agentic swarms to go help fill out, the research that's necessary to make progress towards that, accelerating the pathway to those outcomes. So this is just an example of how that can be done. This is for creating a tech tree for achieving composite learning, so decentralized training of machine learning and doing so on not just the latest GPUs, but a broader set of hardware. There's some guidance principles up there at the top for how to do so, and this essentially creates then you'll see here in a second, a more mind map style tech tree that is literally taking that goal, breaking it down into different technologies that you might need to look at, the different challenges to achieve those technologies, and the new technology solutions that might help you overcome those challenges, and does so, again, in a way that you can then share with experts to get input on, is this right or is it not? So kind of you can call BS quickly on where it might be hallucinated or where there might actually be other ways that are better. So it's creating these high bandwidth communication methods between your agents and scientists. Now, the follow-on piece is that, of course, human input is great, but you can also now use agents to verify. So this gives an example of how you can do so. This is kind of this idea of using an external agent. So if we take one of these nodes, for example, this is then given a summary, and this is fully generated by the LLM, so you might say, hey, is this right or not? So we created an integration with PaperQA, which is an agentic system from FutureHouse, and here you can then basically take that node as input. It translates it into core series of literature questions that you want asked, and it's asking that of the literature, and then basically giving you a response with citations from the papers that it's checked. And so in this case, you're able to basically map a domain, enrich that domain, have human input, check it with external agentic workflows in a matter of minutes. It's pretty cool, and it means that you can create this high bandwidth communication process with the experts. And so I think those were the main things I wanted to show. Now, one thing that I want to mention that I don't have a demo of here, but if you're interested, come talk to me, is that to the theme of knowledge graphs, I'll speak to it at the end of my presentation briefly, but you can also have as an input a JSON, like basically JSON as input. So if you have JSON coming out of a knowledge graph, you can put that into your flow, and you can play with different analysis pipelines on top of that. So it's just to say it doesn't have to be text as input. This is the beauty of LLMs as well, is that there's diversity of how you can transform between different formats. For example, we have one skill that a group has been starting to test where it's checking for the reproducibility of research, where they basically can first do the evaluation in more natural language, but then take the output and translate it into a JSON format that they then take further. So that's just to say you're not purely stuck to kind of traditional text as input and output. So what does this mean? Well, it means that you have these verifiable skills that you can co-develop with scientists and get to a place of comfort that you know they'll be operating at the right level, and then you can empower your agents with these. We have an initial Eliza plugin prototype. We'll probably need to update that for V2. Sean could probably give me insight into how big a lift that is. But essentially, this means that your Eliza agent can call these skills as tools. And I think Sean mentioned yesterday, to the millions of agents that we want running, that's what, you'll basically have this at scale, and it can run this expertise at scale. And that's a key theme of ours, is basically how can you scale expertise? This is a great way to do so. So overall, a last piece that I want to mention is that we're working with a broader set of stakeholders in terms of the community. What's exciting, we actually now are also on the pathway to onboarding more state-level R&D agencies, like universities. This is getting the broader ecosystem of this is now growing quite rapidly because I think the appreciation of the need for these capabilities is growing as well. So the way that we're building is also with a view to creating composable environments so that, for example, these tech trees can identify dependencies or challenges that need to be addressed, and this can then identify the research and experiments that need to be addressed in an open source environment where data is coming out of each of these layers, they can go into multiple model training mechanisms that then improves the overall system. And so that's why we're very excited about open source as being kind of the underlying layer of all this to enable this type of composability and interoperability across the user bases that we see. And to the programmatic incentive side, it means that we have pathways to also looking at actually then, let's say you create this tech tree, being able to say, I want to allocate funding to this problem, and then you have others who can join to that and pool funding there in a programmatic environment where you have dependency graphs where all of this can flow back to the initiatives that have helped solve it. So this is just to briefly speak to the retroactive piece of this where by doing this in this way, you foster an environment where you can have individual expertise aggregated towards solving societally beneficial outcomes and have then the contribution and dependency graph that you can fund retroactively to accelerate everything, essentially. And so one little tease is that in the spirit of this and in the spirit of verification, you'll be hearing from Jay from BARD in a second, but we're also setting up a bit of an experiment, which is essentially a decentralized social gamified experiments for verifying the outputs of systems, where you'll have different types of knowledge graphs or world models, so to speak, generating outputs that then go into different hypothesis generators. And we're likely going to be working with, for example, AT protocol, which is a decentralized social protocol, where you can log in and you can basically engage with the output on an ongoing basis to give feedback into how well the system is performing. So our whole goal is basically to create an at-scale environment that allows you to verify the abilities of these systems, have the ability to reward those that contribute to doing so, and accelerating everything along the way. So this is a tease of it. We can announce further details very shortly, but it will create an environment where you can basically assess the performance of different systems and through that assessment actually provide training data to improve the overall systems along decentralized principles. So in summary, if any of these things sound interesting to your initiatives, if you're interested in tapping into the multidisciplinary expert network, if you're interested in having a library of verified scientific skills, and as we bring in the programmatic incentive system, this sounds interesting to you, please get in touch with me. This is a QR code. It has a type form. You can enter your details there. I've also asked Eric to share the direct link I believe on the YouTube stream or in the Telegram group. If you share your details there and what you want to do with the project, then we can take the conversation and look at how we can bring you on board. So yeah, that's I think all that I wanted to share at the moment. I'll be around also. I believe there's a lunch after this, so I'll be around for that. So feel free to approach me if you have any questions. And yeah, thank you very much for listening.
Any questions? Yes.
Hello. Yeah. Hi. I had a question going back to you had one slide where it was showing how an eval system would go back in loop. But my question is broadly, I would love to just hear about your experience with working with eval systems throughout your work.
I mean, so yeah, our focus has been very much on what I would say is we've been looking at the manual side of things very closely. So putting literally Google Sheets in front of scientists, to that level of manual. So I think at this point, we've mostly been looking at kind of setting up that loop so that we can get very specific answer from specific scientists rather than fully automated processes at this stage. However, if you're interested in the gold standard from my perspective on a lot of agentic science side is what the approaches that Future House take for the development of their agentic systems. So that's where I would kind of point the direction on in terms of how they've benchmarked their agentic processes. And what we're trying to do is basically kind of move towards the hybrid of those two things. So yeah, that would be my kind of slightly non-answer, but hopefully it gives some input.
Appreciate it.
Sorry. You have a question?
Any other questions? But I'll add that I think last week OpenAI came out with it's called Paper Bench, where they very interesting paper on evaluations and working with the researchers behind papers to create a rubric. But
yeah, and I think like what I'd say is that with a lot of the work that's being done today, what we want to do is bring that out into the open. So I think that the interesting thing with a lot of the research, like there might be outputs that come at the end of the process to some degree in a paper or a model eval or whatever it might be. I think what we want to do is create a live dynamic environment for these discussions to be happening on an ongoing basis that is open to everyone to see. Because it's really like, I think one of the tricky things at the moment is kind of when you see these systems being developed, is just there might be a huge variety of different ways that the outcomes were achieved. Like I think with Google co-scientists, there was a lot of expert human-in-the-loop feedback processes in those things. They had amazing results, but it's kind of, we want to make that discussion and really understand, are there certain fields where it's actually performing a lot better? Like, where is the diversity of these systems' capabilities? Like, what is the state across different scientific domains, rather than kind of hype statements? So I think it's like, I think that's somewhat tying both of your comments. It's kind of how can we bring that to a kind of dynamic environment? And I think this community is a great place to do so, so that people have open discussions of like what is and isn't working, basically. Just to riff on that. Sorry, there's been a question in the back from the get-go. So.
Thank you so much. I'm a scientist, so I've learned a lot throughout these sessions. My first question comes to, in order to maintain this dynamism, do you guys have a system in place to check for any papers that have been retracted so that the knowledge always stays the same? And then for your human scientific experts, I'm from Cameroon, West Africa, and one thing we've always noticed is that a lot of the scientists chosen for certain things are from the global north. So a lot of the expertise from the global south, or even, for example, Asia, like where they are the big experts for dengue, but they are not the ones being chosen to be given their expertise on dengue. So have you thought about including people not just from the global north, but also from the global south?
Yeah, absolutely. And that actually kind of dovetails to what I wanted to mention, or what I mentioned there, is that we want to create like an open environment that encourages, as many voices as possible, rather than these kind of closed conversations that often exactly suffer from that problem. And I think this extends also to, principles of the use of data. There's like the FAIR principles, there are the CARE principles. I think there's a lot of additional layers that we hope to encourage in a much more open conversation. And the work that we do is very much seeking to speak to basically contributors from around the world, essentially. So it's definitely a central part of what we're trying to do by building all of this in the open as much as possible, and also making the output maximally a public good so that everyone can build on that resource, essentially. So you both benefit from the diversity of input and that it can be used by builders around the world as well. So this is, I think, a key theme of building in an open and maximally kind of permissionless environment. And was there a second question? The retracted papers. Yes, so I think it's a really important point and quite an interesting one. I had this conversation on Monday as well, because it's not just retracted papers, it's also just papers themselves, because many make claims, and the degree to which papers are reproducible, I think there's the yes, no error initiative was one that kind of spoke to this within the, let's say, Web3 community, but I think basically, ensuring that there are ways, I think there was a question about knowledge graphs and, if you have erroneous input into the knowledge graph. I think keeping track of these things is going to be very important. Now, our approach to that, a key element is the audit trails of every run. Basically, you will know exactly what inputs are there. So trying to plug into basically databases that keep track of, whether there's something to the DOI that allows us to say, oh, this has actually been retracted. What we have wanted to encourage is that you then literally have an audit trail so that if that triggers an effect, you could see, oh, this decision was influenced by a system that reviewed these pieces of information, one of which is no longer valid. And that could be triggered by a flag that this has been retracted, or it might be that there's an evaluation system that goes through the papers and actually starts applying additional metadata as to whether this is reproducible or not. So these audit trails play a central role for why we've established them for exactly being able to go back and update any decisions that were made based on what has then been found to be erroneous data, essentially.
Great talk, Martin. Always great to hear you present. I had also more of a philosophical question. Along the lines of, so as you say, you're starting to speak to R&D level funding agencies and governments and universities. And as you move towards this potential retroactive reward system, and this will be based on basically the DAG, or the knowledge graph generated, how have you discussed how this is determined? Because assumingly this is based on citation, and already citations are a problem in terms of people spiking their own self-citation and everything. So have they discussed about how this might be remedied?
So, well, the first thing I would say is that citation graphs alone is probably not going to do it. And the second point is that it is definitely an area, to caveat, is definitely an area of open research of how to best do this. I would actually say even before getting to that point, I'm happy that they're getting to the point of self-realization that you're going to need new funding mechanisms to move faster. So I'd say right now in the, let's say, on-ramp to this new world, we're mostly at the, we're going to have to fund things faster point, rather than the details of exactly how that gets done. But this is where, for example, I know even within, have you been following the deep funding project? Okay, so that's a great one to look at, because they've initially been looking at ways to evaluate open source dependency graphs in order to do retroactive funding based on that. And they're now moving over to citation graphs. And there are two parallel initiatives there on how to assess that. So what I would say is that there's likely going to be a variety of different experimental approaches that will be taken. And I think the goal will be to evaluate, to do smaller scale experiments and see how does this work. And also, I think the great thing now is that with these new mechanisms, you don't just generate the citation graph, but also contributor graphs of input into these processes. That means you get new sources that could be taken into account. And so I would say you'll have a richer data set, basically, that you can consider when you're looking at the retroactive side. But the beauty is that it encourages them to do things as maximally transparent and open as possible. So I think there's some virtuous cycles that can be initiated. But there is going to be a phase of experimentation necessary to refine how exactly to do that. But to that experimentation, I'm a big fan of diversity, basically, in terms of there's not going to be one size fits all, but rather set up an environment where you could have competing systems, and then you will find different incentives for optimizing how that works. So yeah, that's a big theme for us, is kind of how do you create an ecosystem where you can set up these experiments, share the know-how, and find the best practices, and then optimize and iterate from there, essentially. But yeah, I would definitely check out Deep Funding as probably they're also doing a lot of their work in public around essentially they create this weighting system, and then they do a random sample of judges, and then this is there's a scoring system tied to that. So that's a very concrete example to look at.
Alrighty, we're going to have this one be the last question.
I have a question about FAIR.
About, sorry?
FAIR. FAIR. FAIR ecosystem.
Oh, FAIR. Yeah, sorry. Yeah.
Yeah, so I understand about citations and I understand about data sets. And how about data level? So usually if you have data set, sometimes I have persistent identifiers like DOI, but in most of cases it's not available. So it's not sustainable, it's not fair. And I mean, the graph is moving, right? And you have column names as variables, so you can do something with it, but as soon as it's not sustainable, you have to do something, right? So you assigning your own identifiers created by infrastructure, or how you do that?
Yeah, so we haven't, at this stage, we haven't gotten to the point to answer that question. I would say is this, we're at this stage where we've mostly been focused on setting up these pipelines and evaluating just that the output is good enough, to put it that way. So we will be looking to exactly have those conversations of how to best now publish that, essentially. And so I think Eric from FAIR was at an open science event that with a lot of people looking at the metadata side. So our goal will be talking to those experts on, okay, we're creating this new artifact. How do we now best make it available? So yes, it's an open question, but we are already speaking to the people, essentially, that we want to speak to make that optimal, essentially. Yeah.
And a great point to that is the use of decentralized identifiers wherever we can. A lot of
100%.
stuff with POIs, a lot of stuff with IPTs,
Yeah.
continuing to build out some of those frameworks.
And the event in Denver was hosted by John, working at DeSci Nodes. And,
Exactly.
they've been carrying the flag on a lot of those things.
Alrighty, so that was the last question. I believe coming up next, we have, if I'm not mistaken, it is Origin Trail. So this would be George. Yeah. All right.
Hi, everyone, and thanks, Martin. That was a very interesting talk and discussion. And I have, a couple of things that slightly overlap also. But first, welcome. Very happy to see you all here. My name is Yuri. I'll talk about Origin Trail and how you can use the decentralized knowledge graph to build DeSci agents. And I'm also here for the rest of the day, so if you have any questions that we're not able to cover by the end of the session, feel free to just pull my sleeve and we'll have a chat. Now, just starting with what Martin actually already mentioned in his presentation, right? So LLMs, I'm pretty sure everybody in this room agrees that they're fantastic technology, very powerful, but they're also not super reliable, right? They can trick you, I believe is the word that we use. So there's a quote here from Gary Marcus, who's AI's leading critic, that he calls LLMs brilliantly stupid, right? So on their own, LLMs are not exactly, so they don't have all of the characteristics that we would want to have in an AI system. And those characteristics, what are they? What is the AI ideally, right, that we would have? What does it have? So it's reliable. It doesn't hallucinate, right? You can always trust that the output will be something you can, that's true. It has some form of information provenance so that you know that where the answers that you're getting are actually coming from, where they've been sourced. There's some fair exchange of value and incentives for new knowledge to be produced and added so that the AI system can access it. Multiple contributors, I think that's a very important one, right? We don't want it to be single source. We want this to be a collective thing. And of course, we want to have something that enables data ownership and data privacy where needed. Now, looking at this, looking at and taking in all of these characteristics, really what we want is some form of collective intelligence. And I think Jan LeCun's quote, he's a Turing Award winner, here sums this up really nicely, right? So we need to crowdsource this because if we want to have a repository of all human knowledge, everybody needs to contribute to it in some form or shape. And this is really what Origin Trail is all about. So it's about bringing together a trusted, collective, and neuro-symbolic AI. So that's a lot of adjectives. So what does it mean? Neuro-symbolic AI means we're combining two sides of the AI brain. So we're combining facts with creativity, facts being represented by the symbolic knowledge graphs, right, which are deterministic. They have logical reasoning. They have rule-based inference. They're a lot more, let's say, structure-based. And on the other hand, we then have creativity represented by generative AI models, large language models, and the likes, which are more probabilistic statistical predictions, right? Natural in a language input and output. And when we combine those two, we get something really powerful. Now, what Origin Trail adds to this combination is actually something that is extremely important as well, and that's trust. So we have this, does the laser work? Yeah, here. So we have this trust layer here. And if we look at what does this trust layer mean? So we have the knowledge base in the middle, which is this decentralized knowledge graph of connected knowledge from various different sources. And for each piece of that knowledge graph, we are actually able to verify the source. We are able to verify where that piece of knowledge came from. And that's enabled by this trust layer, which connects to multiple blockchains for that purpose. And each piece of knowledge, which we call knowledge asset, is also represented by an NFT. So that's part of the verification, but it also provides this ownership capability so you can actually also transfer a piece of knowledge to someone else. A couple of scenarios where this would make sense are, for example, marketplaces where you would want to sell your data for something, for tokens and to researchers so that they can use it and so on and so forth. But so we have the trust layer, we have that knowledge base. What this means for that third layer, which is the verifiable AI, is that we can then build agents that are able to retrieve data from this decentralized knowledge graph in the middle and provide answers to our queries or questions, do analysis, but always able to know where the source is and what the source of the answer was. And it can be, you know, that sometimes you would have an agent running on something, might be an answer composed of knowledge coming from 10, 15, 100 different sources, which is ideally what we would want, right? We want that collective intelligence, but we also have the ability to choose who we want to trust in this way. So we have sources of knowledge that we know we don't trust. We can also tell our agents, listen, I don't want you to look at this, right? So that's in a nutshell what Origin Trail is all about. And taking it like one level deeper, just before we go into showcasing some of the demos, like how, like a little slightly more technical. So we talked about retrieval augmented generation, or RAG, before, right? So if we think about RAG as mostly retrieving input from a single source, like a database or a group of databases owned by a single contributor, like yourself, for example, you might have a database on your computer, you might have a folder with your files in them, and so on and so forth. You would run or a knowledge graph running on your machine, right? Or on a server, you would retrieve it, retrieve from it, and send it to the LLM to get an answer. Now, decentralized RAG enhances this by having an agent now not only looking at that one database or folder or whatever that might be, but actually looking at it through all of the contributors, all of the knowledge available on the decentralized knowledge graph. And that includes publicly available knowledge, which would be distributed across these core nodes that is accessible to anyone, right? So everybody it's publicly visible. And also private knowledge, which will be distributed across these edge nodes. And I'll talk about the edge nodes a little bit more as one of the core tools for you to build on the decentralized knowledge graph. But the outcome is kind of what you can do with this is that you have agents that can access the public knowledge. They can, if they have permission, also access private knowledge, do some analysis, do whatever you would design them to do, retrieve, and then retrieve or provide the answer, and you are always able to verify, right, where it's coming from. You're able to not only have this huge knowledge base of connected knowledge, but you can trust the source. And one of the cool pieces is we mentioned Oxygraph as one of the options before. We're actually adding support here on the edge nodes. I'll talk about it a little bit later, but we are adding support for Oxygraph to also be one of the graph databases you can use in the DKG. So you can actually combine the two to get the best of both worlds, if that's where you want to go with building your agents. So that's on the decentralized RAG. Now, how does this look like in action? Just a couple of examples, and I think the first one will be the most. It says something. I think that it won't. Is the computer not connected to the internet? Because I can't play the video. Oh, maybe it's here. Yeah, can someone maybe have a look at this? I think this one would be, this is not, I thought it was embedded in the presentation. Okay, let me, let me get back to this one because it's kind of the most relevant one. But I thought it was embedded in the presentation. So it's a SciGraph. It's the decentralized science paradigm that one of the organizations, ID Theory, was also building, and actually shows how you can use the edge node and the DKG to build the agents and actually add scientific papers to this paradigm. But let me get back to this so that we don't lose time. I will try to get access or check if actually this is a link, but I'm pretty sure this is an embedded video, so I don't know if I can do much. Can I can't control on the laptop. No. But how do I go back to full screen? It was slide 12. No, sorry, go to slide 10. All right. So just going on beyond just DeSci, just to show you the breadth of how you can use or how the decentralized knowledge graph is already being used. One example is with an AI-powered repository with Swiss Railways, where we have a similar thing. So we have the Swiss Railways and their suppliers all exchanging actually supply chain events, and then we have agents doing analysis on this, predicting things like, when would you have to change a wheel on a train before it actually breaks, so with this predictive maintenance. So it goes really beyond all of just the DeSci world. We have Origin Trail Solutions running for example, Trusted Factory, where they're securing security audits for over 40% of US imports. For pharmaceuticals tracking, food and beverage traceability, we have a whiskey grain to glass solution in the graph where agents can understand where the provenance of the whiskey is, how it was matured, and all these types of things. So it's very broad way of you can use it. Of course, in this case, we're talking about DeSci, so the first one will be the most relevant for you, but the question of the hour is, how do you build on the DKG? So what's the stack that you have? And we have two major components. We have the Chat DKG Builder Toolkit, so that's the unified toolkit that enables you to publish, interact with knowledge, deploy agents, and launch paranets. We'll talk about what a paranet is in a little bit as well. And then the DKG Edge node, which is, you can do all of these things, but running your own node gives you a lot more flexibility and control in how you do this. So you take a bit more control of your stack, and it also allows you to do, of course, certain things. You can publish private data and private knowledge and all these types of things. So these things also, they work hand in hand together. So if you put them together, you get something that is a lot more powerful than each of them individually. Now, what's in the Builder Toolkit? We have the DKG Software Developer Kit, so libraries to interact and connect to the knowledge graph and interact with the knowledge in it. We currently have JS and Python SDKs available. So all of this, by the way, I have a QR code in the end. You can scan and access the docs, and you can see all of these things in a lot more detail. Knowledge paranets is the other major component in the toolkit, which will be very interesting for you. What are knowledge paranets? If we see the decentralized knowledge graph as the one kind of large piece of connected knowledge, you will have certain sections. You can have certain sections within it called paranets, which focus on a specific topic. So for example, you would want to build a paranet around neurological research, and then it's much easier also to direct agents where in the decentralized knowledge graph to actually look. So there are collections of knowledge assets, but not only knowledge assets, also agents, services for a knowledge category that you as a paranet team can define as you're building the paranet. So you can use also customized incentives, AI models, ontologies, quality controls. We talked about before. We talked about how do you ensure, for example, if certain papers were revoked, how do you ensure that they're no longer in the graph? This is an example of what you could build into a paranet. You have an agent that checks, the DOI identifiers, finds the ones that have been revoked, and actually flags those particular papers in the knowledge graph so that the agents know not to look at them. Just as an example, right? And we also have human-in-the-loop incentives. So if there is a paranet that you would like to create that has knowledge that you think would be very valuable not only to you, but to other builders across the decentralized knowledge graph, you can actually submit a proposal that goes for that paranet that goes to vote via on-chain governance. And if it's passed, if the community says this makes a lot of sense, there are actually rewards in form of the Neuro token that are unlocked, meaning that when then people who contribute to the knowledge paranet, who add resources to it, are actually getting also rewarded for that piece. So that means that we're growing the knowledge base that can be used for you, by your agent, with your agents, or by anyone else who has who is building on the DKG. So that's One thing, I think this one will be important, so agents, so creating, expanding AI agent memories in a verifiable way on the DKG. We have, Sean already mentioned before, the Eliza OS DKG plugin, but you can also build your own custom agents that interact with the DKG in ways that you would want to do. But I believe that the focus of the hackathon is on the Eliza OS framework. And then we have the edge node. So the edge node is, as mentioned before, you can do all of these things on the public infrastructure, meaning that you can use some publicly provided nodes, but that gives you a lot less flexibility in terms of how you define, how you deploy agents, how you run your paranets, how you interact with your knowledge asset. Running your own edge node also allows you to have private knowledge, and it just gives you more flexibility overall. And it's very easy to run. We just released a new installer for Mac OS yesterday, so it takes really just 10, 15 minutes to set up, to give it a spin, and then you can configure it the way that you want to. And this is really the architecture of it. There is the edge node is a collection of services, and there are a couple of services that will be interesting for the builders to kind of modify, and that's or customize and build. And that's the knowledge mining API, the Decentralized RAG API, and the edge node user interface. Those are, we have some boilerplate services set up for those, which you can then take and kind of enhance and actually build on. And we have examples of those specifically related to DeSci that you can actually look into a bit closer. One of them was the video that didn't play. So it's a group of agents, for example, that can take a PDF of a scientific paper that is focusing, I believe, on neurological research, and decompose it, run through it with apply all of the ontologies and create a semantically rich graph, puts it on the DKG, and then you can use it to query. So that's kind of, we have some of these examples available. You can use them, you can build on them, and make them better, adjust them to your needs. And of course, you can also add, because it's a modular architecture, you can add your own services at any point in time to the edge node. So it's a very powerful modular infrastructure to interact with the DKG. That's it from my side. So I would invite you to scan the QR code. It gives you links to all of the docs, the website, the Telegram, and the Discord community. I don't know how much time I have left. I would really like to try to get that video working. I don't know if I can quickly check. And I'm also happy to answer any questions you might have. Yeah, maybe we start with questions.
Sounds great. So first and foremost, we would love to thank Origin Trail for being one of the gold sponsors for the event, and we at BioProtocol are grateful for the opportunity to be able to build on top of a fantastic tech stack. So thank you for that. So questions?
Hi. My question is, I think pretty much every team here is working on knowledge graphs, certainly with Origin Trail. So broadly, I was curious, I'd love to hear about kind of some of the lessons, maybe like things you've seen work out well when it involves building out these knowledge graphs, abstractions, etc.
Yeah, it's a good question, and I think there is, with LLMs, it's also becoming a lot easier to build knowledge graphs. I think it's kind of like a symbiotic relationship, and that's what the agents that I mentioned also in the knowledge mining pipelines and with Eliza OS, you can actually use these examples that we have to help you build those quality knowledge graphs that you can then use to retrieve and do analysis, right? Find gaps in research, and even do autonomous research, hopefully soon by agents themselves. Now, how you build high quality knowledge graphs themselves will also depend on the area that you're in, because one of the core components of knowledge graphs would be finding and applying the right ontologies to it, right? So if you find the right ontology, then the description of what you're getting from, for example, a research paper or whatever, the graph that you produce from it will be a lot more rich and be able to be understood by machines, agents, but also people, right? So ontologies are, I think, are a core component of it, and I always suggest to put focus there, because that's what really creates I mean, that's the main part about knowledge graphs, right? It's also the main difference between JSON and JSON LD is adding that context, which applies to, to everything we do in the knowledge graph world. Not just one ontology, by the way. The example that you will have available, I think we use 7 or 8 different ontologies. One is for citations, one is for biological processes, one is for results of the paper. So, you need to have a very comprehensive approach if you want to capture and create something that is extremely rich and semantically detailed. I hope I answered the question.
Yeah, thank you.
One question from my side. Does Origin Trails support subject, predicate, object triples?
Sorry, can you repeat?
Does it support RDF?
Yeah, definitely. So that's one of the things that I wanted to mention before. So because Oxygraph is also an RDF and Sparkle database, that's why so it makes sense. It's one of the components, right? The graph-based database is one of the components of the, and it's already gone. So it's one of the components of the edge node, right? And you can replace it if you want to with anything that is currently supported, which is BlazeGraph. We have Amazon Neptune, and Oxygraph will be available in the next days. All of them are RDF Sparkle databases that you can just plug in and use on your edge node if that's what you want to do.
Thank you. Looks fantastic, honestly. Congratulations. So my question is about sensitive data support. I understand that infrastructure in principle ready, so this distributed RAG should be doing job, and how you are dealing with it right now?
So yeah, that's a very good question, because obviously when you hear public, knowledge graph, that's how do you deal with sensitive data? The thing is, you can do on the DKG, you can do both. So you can publish certain things publicly that it's available to everyone. You can publish certain knowledge assets privately just on your node, and then give access to certain individuals, organizations, whoever, agents you want to give access to. Now, those private knowledge assets, they are still secured by the DKG. So you still have the data fingerprints. You can, on blockchain, you can, it's still backed by an NFT. It's still transferable, but it's still verifiable, right, in terms of source. But the data is not available on the public graph. It's just available on your node. And if you have an agent that has access to this, then you can do it, right? Then you can get it.
Yeah, that's clear. So just imagine you have a data node, right, with sensitive data, and you're basically mining metadata. So some sensitive information can be also available in metadata, which should be not shared with public nodes.
Yeah, you can decide that there can be absolutely no metadata shared if you don't want it to. But give you a quick example, right? One cool thing is that we showcased a while back is you might have wearables data of your Oura Ring or your Apple Watch that for the last month of your sleeping, of your activity and exercise regimes and heart rate and all the data that you have there. And you want to now ask an agent to do an analysis and recommend improvements, right? Now that agent could access that data because it's yours, right? It's private, but it could also access data on latest scientific research on the DKG to find, what is the latest research, what are the latest recommendations, combine the two, and provide a comprehensive answer. And that's the cool thing. That's the decentralized RAG, right? You combine stuff from different sources, always able to track back, but you get that power of connectivity.
Cool, thank you.
All righty, this is the last question.
Thank you for the great presentation. I wanted to ask about how, if you have a way to include the experimental knowledge also in these graphs. So not just what is published, but also a feedback loop maybe where, experiments can be repeated in different labs and a sort of scoring system that says, okay, this protocol that it's published, it's actually worked in 5 labs or so. Because even Nature papers, sometimes they are not reproducible. So for this.
Yeah, there is and that's an interesting question. I think it's also kind of been a red thread of the last couple of presentations is how to also flag certain pieces of knowledge in the knowledge graph, how to update them, amend them as they become, as more becomes known about them. And one of the things, it's currently not, it's still in development, but it will be available very soon, is also a way to update knowledge assets on the decentralized knowledge graph. So if you have a piece of knowledge that you publish, right? That at a certain point in time, then it becomes clear that you know, like I said, it's not reproducible, it's been revoked, it's not relevant anymore. The owner of the knowledge asset can actually update it with the latest data, and that would be trackable, visible in the on the blockchain as well, because you would always able to see what happened to the piece of knowledge. So if somebody changed it, updated, transferred knowledge, it's all kind of traceable back to the source. And that's something that you'll be able to do very soon. And you can also play around with having some of this data, for example, private until it's ready to be public. We also have a test net where you can try out before you go to the mainnet in public. So it depends really on the exact situation. You could even do some detailed rules and process implementations in the way you launch a paranet, right? So that you have some checks implemented on that level as well. So I'm happy to talk more after, so that I won't take too much time. But it really would go. There are several mechanisms. It just depends on how you'd want to implement them.
All right. Well, thank you very much.
Yeah. Thank you, everyone.
And up next, we have a virtual presentation from Jacek Weiland of BARD. So Jacek, welcome to the stream.
Hi. Let me just. Can you hear me well?
Yes, we can. Can you maybe speak up just a little bit?
Right.
There we go. That's better. Thank you.
Okay. Go this slide.
Hey, Jacek. You're on the stream now.
Yep. Right.
Oh, I'll come back.
Right. With, uh,
Do you have a way to share your screen? I think there might be some connectivity problems here, Jacek.
yeah. Wait.
Just take us to break here. Let's go ahead and put something up on Tuesday break. Alrighty, everyone. We're having some technical difficulties with one of our virtual presenters. So while we get bandwidth figured out there, we're just going to go to a quick break. So for anyone who wants to use the restroom, grab a cup of coffee, take some time to stretch, feel free to. We'll be right back. Thanks, y'all.
Jay, you should be
Hello?
able to hear us.
Can you hear?
Can you answer me, please?
I'm just
Hello?
hearing you now. Hello?
Again, please. Didn't hear you.
Hello?
This
Can
is
you hear me
Norm.
now?
Yeah, it's the microphone sounds pretty reverby. Is it the microphone from the laptop, the internal?
Yeah, it is the internal one. How is it now? How is it now?
That's better.
Yeah. Right. Is it good now?
Yeah, there's a lot of
Um,
background noises, so you're
it
pretty
should be
low
better now.
in volume.
And now I just changed the room, thinking maybe it will be better.
Yeah, maybe if you find a secluded room where there's no one else, and then try to speak like maybe only like a couple of inches away from the microphone. I could share your slides and then also go to the next slide if you tell me. So maybe say something again.
Like it's big problems with understanding what you're saying. I'm wondering if.
But do you hear me?
Yeah.
Or can you hear me? You can also write in the chat here. And if it's possible, connect yourself with a cable to the internet, not wireless. That maybe gives a bit more stability. If you can't understand me, it's probably your connection, because we have like 800 upstream.
Hey, can you hear me now? Well? Hello?
Hello, yeah? Again? Please say something. Again, please. Okay. Now he's left the room again. I don't know.
This may just not happen.
I don't know if it's his connection or. So sorry for everyone already listening. We're just doing something technical, a couple of technical tests. We will maybe then not start in a few minutes. So
Hey,
Jay,
can you hear me well?
can you hear me? Again, please.
Yeah, now I can hear you. Yeah. How is it now?
Sounds bit better on your side.
Okay. Yeah, might be a problem. Not sure. Like the internet seems to be working here, but I can't hear you well.
Okay. Check 1, 2. No, it's nothing from my side. Yes, it sounds okay. It's a bit low in volume.
Yeah, I mean, just the thing is, I can't. well, but if you guys can hear me well, then I guess there is no problem. Yeah, so I leave. Well, but as long as you can hear me well, I am good to go.
Yeah, your connection is a bit disrupted. Actually, I
Okay.
missed half of your
Now,
sentence.
I think now I can hear you well at last. So what I was saying is, if you can hear me well now, I'm good to go. But if not, I guess we can think of something different.
Yeah, it's more about Eric's decision about your connection. So at the moment it seems stable, but I don't know.
Right.
It's his call. So maybe we'll wait for his call. He's
Cool.
outside. So
All
maybe
right.
just stay in the room for like 1 more 2 minutes, and then we can decide. Thanks.
No worries. I'm here.
Yep.
Pretty simple. Just click here, right?
Test, test.
Alrighty, ladies and gentlemen, we are gonna go ahead and get started again. So hope everyone enjoyed lunch, a little bit of time off to chat, to eat, to focus on things. And coming up next, we have Kevin from Molecule talking about POIs and IPTs. So with that, Kevin.
Thank you very much. Can I make this higher somewhat? I guess. Yeah. Easy. Test, test. Attention, please. Oh. The mic to me? Of course. All right. Yeah, easy. Cool. Hi, guys. I know a lot of folks from VitaDAO here, so I'm going to steal their tagline. How great is it to be alive? Woo! Nice. Sorry, just had to get this out of the way. Cool. I'm Kevin. I'm the head of product at Molecule. We are in this beautiful office. This is our home, so welcome to our home. I hope you enjoy this. This is our living room, more or less. I'm going to be talking about Molecule. What do we do? What's our mission? What's our vision? What are the beautiful products that we're launching? And yeah, how this all fits together also with the hackathon here. I'm super stoked to have you here. Let's get started so I don't bore you. Cool. Let's start out with our vision, or mission actually. Maybe you heard about Molecule before, maybe you haven't, so just a quick recap. What are we doing? Basically, really small vision and mission is we want to change the way intellectual property is actually created and managed on-chain. So what are we doing? We're building a protocol and also an exchange for on-chain scientific IP, especially towards biotech. The main goal for us is basically turning siloed research into liquid markets powered by open data. We really want to bring decentralized into science. That's why we coined the term DeSci. Cool. Let's dive right into things. Yeah, this is how we see it. Oh, slide is a bit messed up. That's on purpose, just trying to see if you pay attention. Yeah, so left side is traditional science, so something that is moving but a bit slower. And on the right-hand side, this is how we see DeSci, right? Formula 1 cars, super fast. Not a car guy, by the way, so don't pin me down. But yeah, this is how we see ourselves. Science is usually quite expensive, a bit slow. We're trying to optimize this. We're trying to be leaner, we're trying to be faster, and we're, of course, trying to be more capital efficient in all of this. Cool. Yeah, I don't know how long you've been into DeSci, but we had a really, really cool moment end of last year, the DeSci moment, and we're doubling down that this is not just a point in time, but is going to be the main narrative. Actually, it was last year, November. We call it first slowly, then all at once. Crypto mindshare was pivoting drastically. We're basically almost flipping DeFi, which was amazing to see. Got a ton of attention, ton of people testing our products, which was amazing. We raised a ton of money for science on chain, helped basically fund 7 different projects just on the Molecule side. I think almost raising 2.5 million. So yeah, super cool to see this, and we of course want to double down on this. Yeah, this is probably a good explanation about DeSci as well. I don't know how crypto friendly you are, but DeFi in essence is self-custody of your health, and DeSci is self-custody of your health. Wealth and health, yeah, heart. English is hard. But yeah, this is how we see it. So we want to enable people to custody their own health, bring people together that are either scientists, communities, patients. That's, I guess, the TLDR on things. So what does Molecule do in all of this, right? What's our way forward to contributing to the space? Molecule's protocol. Cool. Let me explain you what this means. So what we've built actually last year, and this is the thing that we want to do, is we want to bring science on chain, so basically the supply side of things. We launched a product end of last year in November, actually, which is called Proof of Invention. I think the easiest way to describe it is a timestamping service on-chain to basically prove ownership and provenance of your idea. So no matter whether that's a picture of a napkin, a deep file system, basically, or just a white paper, you can prove on-chain that you had this idea. It's super cheap, super fast, literally takes you a minute. Really encourage you to test this, poi.molecule.xyz, also for the people watching online. And a fraction of a cent. Cool part, globally portable at any given time, so you can just take your ideas with you. I think the best explanation for it in the real world is sending yourself a letter, actually. So we ported that into the crypto world of things. So think about it this way. You have your amazing idea, whether that's a recipe or, I don't know, groundbreaking idea that you think is going to change the world. You write this on a piece of paper, you put this in an envelope, you send this to yourself through the letter, to the post office, and you basically get a stamp on your idea from the post office that says, on that day, this person had it, and we basically put a stamp on it and says, cool. There's some, let's say, centralized authority that acknowledged on that day that I had this. Whether I expose what's in that letter or not, completely up to me, but I have proof, basically some form of tender, that this happened on that day. We do the same thing, but on blockchain, which is super cool. So immutable timestamp on a public ledger. We at the moment offer Ethereum and Base, but in theory you could also use testnet. There's more coming, Solana, Sui, you name it. But at the moment we started with this. So immutable timestamp, you are in full control, so nothing is leaked about your idea. We don't store anything. So I guess the crypto term is not your keys, not your coins. Not your data, not your POI. So you have to actually keep custody of your data as well, right? It's not something that you leak to us as well. So we don't store any data, but in essence, what we're doing is you present the data to the app, we hash the content, and basically create a Merkle tree underneath, and then we just write the top root hash on chain from the wallet that you used. The cool part about this is you can use an EOA, so MetaMask, Phantom, whatever, or you can just use your email and your password, and a wallet is created for you to use it. So we make it super user-friendly, super cheap. Test it out. We tested this in Cambridge with university students. We did this with the DAOs already. We already did one successful pre-sale, I guess you could say, raising almost 200K with Cerebrum DAO. And now all of the new DAOs and the old DAOs are using this to just prove science is happening on-chain, which is super cool. And again, right, this also allows you to prove at any given point in time what the actual idea was. So basically, you open up the envelope, show it to the world. Cool. Why did we do this? Super easy. Very, very top of the funnel, right? Any idea can be on-chain. What this allows you to do in the next step, and I think that's the cool part, is it allows you to work with Molecule's tech stack, or Molecule's IP protocol, if you would say so. So when you have an idea, when you have something on-chain, nothing is visible at this stage. But the next step is actually you can tokenize this into a unique piece of token. So your idea actually becomes a non-fungible token, an NFT. It's a unique piece. It's a one-of-a-kind. And the nice part is it's discoverable. You can add metadata to it. You can add a cool image if you want, such as this one. And basically for us, the way to think about this is it's a representation of a Web3 native way of your IP on-chain. So basically think about it as a token with a legal wrapper that protects what is your IP, your most important thing, close to your heart, needs to be protected, but you can share it. Super easy to do. We have all of the legal guardrails in place as well. So we use something that's a public good. It's called DeSci codes, DeSci.codes, which basically a library of legal frameworks that you can use to protect this. And we use this for our tech as well. So we're working with patent lawyers and legal experts together to really make sure this is waterproof and solid. Yeah, what does this bring to you? Immutable proof of your token. So you have a wallet, you have an asset. You can basically transfer this now, you can sell it. And the way we see it, it's like the bridge between the traditional IP world and what we're calling at Molecule, the digital future. So Web3 for DeSci, for patents, for IP. Super nice. And then last but not least, actually last but not least, but there's another one which is even further down the funnel. So you start with a POI, you can tokenize it into an IP NFT, so you have a one-of-a-kind. And then there's a third step that's even more granular that is called IP tokens, IPTs. So on technical terms, this is an ERC20, so nothing too crazy. But what this actually allows you to do is that you have means to just fractionalize your one-of-a-kind into as many pieces as you want. Can be 1, can be 1,000,000, can be 100 billion. You're in full control. And the way we see it is that IP tokens really allow you to foster open source collaboration without necessarily losing any commercial viability. So think about it this way. I think an easy explanation is, I have my amazing recipe for bread. It's water and flour, nothing special. I use this as a POI to write it on chain. Then I think this is amazing. I want to keep going. I want to let other people know about my amazing recipe, water and flour. I tokenize this asset, and then I can also create IP tokens and invite other people in. So for example, I could invite James in, send him some tokens, hi James, and then basically have James also give an incentive to contribute, right? So maybe James has this amazing idea to now add salt to this recipe and say, wow, that's cool. Then I invite Lucas in, and Lucas says, nice, I want to add, I don't know, yeast. Let's make amazing bread. And then the idea starts forming and evolving over time. And then all of a sudden, we have the best bread recipe out there. And there's a proof record, right? Because now James and Lucas, they also have these tokens that are kind of representing also some, I would say, governance over the idea. So they're also incentivized to contribute and to create something meaningful. So it's a super nice way to invite people in, give them access to, for example, otherwise confidential information, so token-gated access. We can vote. We're basically creating a micro-DAO around our beautiful bread recipe. And then also really crucial decisions, such as like transfer control. We could, in theory, commercialize our beautiful bread and open up bakeries all over the world. And this also would allow, for example, James, Lucas, and myself now to think about, hey, do we want to vote, for example, royalties into the place or anything else that comes with this? Do we want to sell the thing? So it basically allows you to have an idea, tokenize the idea, form a community around the idea, and then really live the decentralized nature that blockchain enables. So super cool tech. But yeah, all of this is just tokenized science on chain. We talked a lot about tokens and when token, but I think the more critical part, and this is where I see Molecule really at its core, is when science. And this is something that we're kind of exploring right now. So to give you also a bit of a sneak peek what we're cooking in Q2, it's really about trying to, we call this IP accounts, IP hubs, name TBD, just leave it here. We want to make science progress more transparent on chain. We want to make this investable, we want to make this liquid, and we also want to make sure that the promise that DeSci has given is actually being fulfilled. So we are working on something that allows you to have verified regular updates on scientific progress for IP projects that people, and for example myself with the recipe, I can decide who I share this with. Is it just the core team? Is it the token holders? Is it something that's there for the public to see so I can promote this a bit more? So it's kind of like an interface for people to understand what the science is behind all of this. So we see this as progress, reporting progress, creating value. Ultimately, that's what we want. We want to drive impact and thereby really creating something meaningful for the space. So when science? Now. Cool. So in a nutshell, anyone to register and manage IP on chain, super easy, super fast. Please test this one out. I'll have a QR code in the end, I think, as well. So bring an IP on chain, protect what's the most important to you, and that's what we call the IP, the idea, the data, but allow for control collaboration. So you're in charge, you can decide who you share your idea with, just as in the real world. You got to be mindful, of course, and you can also use Web3 primitives for this. NFTs, tokens, yeah, and also just really leverage decentralized communities. Yeah, that was a TLDR and Molecule. We also have some other things. I think I have a bit of time. Eric, please interrupt me if I'm running over. But we also did something cool on Solana. So DeSci broke ground on Solana, also end of last year. Big shout out to Benji here, who's not here, but yeah, he's really been driving this forward. Maybe you heard about this, pump science, but yeah, more or less really interesting way to tap more into crypto degen liquidity. So basically being able to live stream experiments and have people in real time validate whether certain compounds extend life in animals. We started off with worms, then went to flies, then went to mouse. I think Benji's best to talk about this, but just wanted to give him a shout out here as well. I think really cool. Yeah, it was insane. It was insane start, literally. Went from 1K to almost 50K followers now. It's an outdated slide. Telegram is going insane. Global communities as well, around the globe. Turkey, Asia, Germany, everywhere. Super cool. Market cap also went crazy. I think in total, yeah, more than 300 million. Both of the initial compounds launched, which was RIF and Euro. Trading volume was also insane. So yeah, traditional science watching DeSci raise millions of dollars to fund critical science within minutes. So super cool to have this also part of it. They're also leveraging Molecule's IP stack. I need to hurry. Okay, I'll try to hurry. No hurry? Okay, cool. All good. No, they're also leveraging Molecule's IP stack. So we have IP NFTs for this. Those are IP tokens. And we want to make sure that all of this kind of feeds into Molecule's protocol. Cool. But wait, there's more. One more thing that I wanted to tease. This is a bit of an alpha right now. This is a product we haven't released just yet, but we're about to. So follow Molecule on Twitter, on Discord, on Telegram, on whatever socials we have. I think I have a slide in the end. We are going to be able to trade the future of science and allow you to have a gateway of innovation into biotech. So this is just a bit of a thumbnail that is coming. I'm super stoked for this actually, and kind of feeds into our protocol vision as well. So stay tuned on the launch. I think this is a really cool product that's going live soon. I can't really tell more right now. So people watching also in the live stream, please follow, sign up to the newsletter. And yeah, I think this was it. Yeah, get in touch. This is the QR code. Follow us on Twitter, Molecule DAO. You can follow me as well. I appreciate every follower out there. join our Discord. My email as well, so don't spam me, please. And thank you. Oh, questions. Jesus. Okay.
That was a very certain hand.
Thank you so much. That was super fascinating, especially for I, who's from a traditional science background, when you talked about protecting your idea, because the one thing you have is junior researchers coming up with an idea that becomes later on the Nobel Prize, but the professor gets it. So how is your platform going to help any future scientists protect their idea to get their Nobel Prize and not the professor?
That's a really good point. I think the way we see it, so just one thing clear from the get-go, registering something on-chain doesn't replace, for example, filing for a non-provisional patent or a patent in general, right? So that's just off the gate, but it helps the case. It's kind of like you have a timestamp on-chain that proves provenance and ownership that you had that idea in the first place. So it basically supports as like evidence in your case, I would say, when filing for a patent. The way we see it and the way we're using it right now, for example, is a good example is, for example, is VitaDAO. So VitaDAO is running a contest or a hackathon as well that's called Vita Labs. So basically, you as a researcher, you can come to VitaDAO and say, I have this amazing idea. Do you guys want to work with me? And then you can use this system to propose your idea to the DAO, and then the DAO also basically you have an on-chain proof, right? There's something there that you were there before they can start running with it after. So it's more like the way we see it, it's like a trail in history, really. Like it goes with the asset from the inception of the idea to the tokenization to all of the steps underneath until you win your Nobel Peace Prize. So basically, yeah, just think about it like as a history, point in history where you basically have proof that this happened on that day. It's your wallet, it's your account. You have the original files, so you can also prove that basically you are the ones doing it. And for example, you can also prove that certain files have been part of that idea. I hope that answers your question a bit.
Hi, I have a question. Is Molecule protocol looking for cross-chain opportunity or more public chain?
Sorry, can you repeat the question?
Looking for cross-chain opportunities? Because I check out it's on Solana and Base right now, right?
Yeah, definitely. So in theory, POI in theory works on any chain, right? It's just basically a transaction that we write on chain with the hash. We just enable it to start with on EVM chain, so basically mainnet and Base. But it's not so hard to add, for example, Solana or Suri, any other. The way we think about this, at least for IP NFTs, was to always have one core chain, like mainnet, as like the core for all of these valuable assets at this stage, and then have the tokens freely traded somewhere else. So this is happening right now, right? It's like the asset lives on mainnet, and then the reference token, which is the IPT, can live on, I don't know, Base, Solana, you name it, Bitcoin, Ethereum, ordinals, whatever you want to do. But there's definitely this multi-chain angle because we see that you need to have some source of truth. At the moment, that's Ethereum. But then we, of course, want to make this multi-chain because, yeah, it should happen on every chain. DeSci is multi-chain, so we are aware of this.
Thank you.
Of course. You can also ask questions after.
I've got a question.
Sorry?
I've got a question.
Oh my God, okay.
So I know like a lot of these examples have been around like researchers and their ideas that they're developing within like either healthcare or science. Would someone at a hackathon use proof of invention?
We highly encourage you to do so. I mean, that's the whole goal, right? So basically, I know this has been the talk of the town this week with everything going around AI agents, but this is exactly what you can do. So if you come up with a cool hypothesis, if you come up with a cool idea for the hackathon, you can use this system right now to just timestamp your idea and basically allow you to also show ownership about what you're doing. And we want to encourage people to just use the system. Give us feedback. We want to make this better, of course. That's a first start, but definitely use it. Literally, that's what it's made for.
Yeah, I have a question. So you gave an example of bread. So let's assume there someone put the idea on coin or something, ITP, the exact same bread idea, and after some days, I have the exact same idea of when I'm trying to put it on coin or something. Will it validate and verify the exact same idea is already available or exists there and tell me, oh, you can't do it, or the same idea of me can get registered and create a future conflict?
Yeah.
How it works there?
Good question. So at the moment, we don't validate whether idea has already been registered before, but what we can do is already just take the first one that was there already. So in theory, you could do it twice, but then only the first one can get tokenized. So there's always like, you can mint the asset, but only towards the wallet that was already there. So it's something that ideally at some point in the future, that's a feature to just validate early on whether this is a novel idea or not. But yeah, definitely subject to improvements for sure. Coolio. No more questions? Silence as acceptance. Thank you very much for listening, guys. I hope you enjoyed this and enjoy the rest of the conference. And yeah, talk soon. Thank you.
Thanks, Kevin. Up next, we have a virtual or a pre-recorded presentation from Vincent Weiser of Prime Intellect, which is going to be an awesome talk. So, Norman, if you could.
Hello everyone, I'm Vincent, the founder of Prime Intellect, and also previously helped start Bio alongside an awesome team that is also at the space. Unfortunately, I can't make it today in person, but so I'll do a brief remote talk, giving kind of like an overview on the one side of what we're building and how you can use Prime Intellect for the hackathon, but also sharing some just general ideas on how to advance scientific progress with Scientific Agent at this awesome hackathon. So I'll kick it off just sharing a bit what we're building with Prime Intellect. So basically we're building a platform for, on the one side, accessing compute. So you basically can find any kind of like GPU from NVIDIA on our platform. And on the other side, we're building decentralized training frameworks, reinforcement learning, etc., to really get us to open source AGI and to solve kind of like the accessibility of AI, but then really also to advance scientific progress and in generally universal access to compute and intelligence. And I think in general to also frame like this like hackathon, from my perspective, I think really the most important thing in general is really scientific progress for humanity. So basically, I think the chart on the left really like a lot of areas of human progress are driven by scientific progress. So really, I think we've basically need to figure out the best ways, like as part of this hackathon, really on how we can make the most scientific progress in this kind of like short 1-2 week period with the current existing tools and like what the biggest promising tools are that we could potentially leverage. And I think what's useful is to also look at the scientific method and at each area of it, from observation to the researching, hypothesis generation, testing with an experiment, analyzing data, to coming up with a conclusion and asking ourselves like which parts of those can we start to automate more and more with scientific agents, but also where in general will like AI progress help us and which areas of scientific progress won't necessarily be solved just by general AI progress. So I'll touch on 3 high-level areas. On the one side, just like setting the context of some things I would recommend reading to set the setting for what you could build within this hackathon. The other thing is like some of my favorite like AI tools and building blocks, a lot of which you might already know. But then also really just sharing a few project ideas. So yeah, just like high level, I think there's a bunch of also good articles about agents more generally and scientific agents. And I obviously already touched on kind of like this idea of using agents to automate the scientific process and process and really those different sub pieces of the scientific process and scientific method. So I think that's very valuable. I recommend you read BioXYZ kind of like AI documentation. I shared a link here, and this diagram gives you also like some inspiration for what you could potentially build. Then 2 other actually amazing pieces. One is this piece on like autonomous science by Mackenzie, really, and she outlines this quite clearly in a similar way that really those areas I also touched on automating the scientific method are really promising to start with. And then there's a great like work by Google on the AI scientist, but also by folks like Sakana AI, which you can check out because they also have a GitHub repo which you can fork and play with, which are basically starting with this premise that you could also automate scientific AI research, as basically it's easier to execute because it also runs on code. So I can recommend this article, but also Sakana AI's article on the same topic. And they break this down also, if you zoom in the different areas that kind of matter, from the scientific inputs to kind of building up this like multi-agent system which can autonomously do the scientific method in essence, and then really use tools and memory and yeah, like basically act as a sort of like co-scientist. Like some of the tools, like obviously for Prime Intellect, like we will sponsor also compute for all hackers, so you can use the code like Biohack 2025 for I think it's like $10 compute credits, but then you can also just ping me at Vincent Weiser or in the Telegram, and we'll send up to $100 of compute directly to folks in addition. And yeah, I think the other thing that's worth leveraging is the BioXYZ agent frameworks. You can probably find Sean or catch him in the Telegram or Discord to get you started. And then I think it's obviously really worth playing with like the frontier AI models and APIs. I think specifically I would recommend like playing with the deep research and reasoning models. So basically, actually Gemini just dropped like a new deep research with Gemini 2.5. I'm not sure if it's available on the API, but it's definitely worth playing with. And I think in general, there's more and more really good also open source AI models for reasoning, and that could basically serve a building block for your agent. I think the other thing is like to just quickly prototype and build, I would definitely recommend like using one of the AI coding IDEs. Basically, software like you might already know, like Cursor, Windsurf, Claude dropped also their own coder tool. But then also there's more like web-based interfaces if you're newer to it, like Replit, or even like Claude. You can do stuff in browser, and then obviously VS Code with GitHub Copilot is also quite good. And yeah, then I think the other thing is like leveraging scientific tool APIs. So Future House has a literature review agent. I think you might need to ping them to get early access, but then there's also a bunch of scientific models, and NVIDIA has also their own BioNemo platform to check out scientific models. And there's a bunch more that you can find, like for example, the ARC scientific models or AlphaFold that is hosted in different platforms. I think Niklas from LabDAO might have shared some good resources on this, so it's worth looking this up. Yeah, and then I think in general on agents, I think there's three pieces to it basically. So on one side it's like the architecture you pick, the problem you pick, but it really like it's powered by compute, it's powered by inference, basically using the models, and then ultimately it's about like getting some specific reward, like which could in the case of BioDAOs be, for example, fulfilling specific tasks and bounties even with the agent. But I think that's like one valuable framework. Otherwise, like I think the challenge can become that the scientific agent is just like mindlessly generating, for example, a bunch of scientific hypotheses that aren't really in demand or aren't really needed. So I think directing it towards something that is actually in demand is quite useful. And this leads me to some of the ideas that you could hack on. So basically, I think like among the scientific agent, I already mentioned a bunch of times, but like there's a bunch of things you could build around that, from like a literature review agent, hypothesis generation agent, data analysis agent. All of these things I think work extremely well with current AI tools. I think what's also quite cool would be something like a scientific debate agent, basically having multiple agents and models play different roles to debate specific scientific, for example, like a proposal for a scientific area. I think another one I'm personally quite excited about is also this idea of like starting with a specific outcome you want. Like, for example, you could take something like rejuvenate the brain and then try to reverse engineer from that what could be basically the different tech trees, the basically different research projects and hypotheses of like that could rejuvenate the brain, and basically exploring them. But I also listed a bunch of others that could be relevant, including even like stuff that isn't immediately scientific but still relevant for science, like playing basically like automating other pieces of, for example, a BioDAO. That could also be something like writing up on some of the science. But I think there's a bunch of other things, but I would orient around those. But obviously, yeah, feel free to come up with anything that you think could advance science. But I think really the core thing I would encourage is like iterating quite quickly and just shipping something, and just using AI to like code some of it for you, and really point it at the things you're most interested in and try to just get it running within minutes or hours, and ship it, share it, like post it on X, on social media, or also in the Telegram and Discord channel to discuss and like sort of form a team to yeah, like accelerate kind of like the scientific agents. And I think there's some like more like prompts, and I think one really thing worth taking seriously is that I do think we're on this exponential trajectory of like AI progress, and I think it's worth asking the question of like, what if AI could literally fully autonomously run the whole scientific process? Like, what would that look like, and basically what are the bottlenecks to get there? And I think it really like the other, I think like mind shift is that really like the scientific method is basically getting a full like autonomy and software upgrade, and it's really just about like figuring out like what are the pieces that might be the hardest to automate, because those will ultimately slow down the whole like speed of scientific progress. Yeah, so basically I think it's worth really taking AI progress seriously in a sense. Like there's some good articles on it recently, like you can Google, for example, for AI 2027, which is like an article about like potential progress throughout the next 3-4 years, just painting one like kind of like exponential progress scenario. Obviously there has been another good article, for example, like called Situational Awareness by Leopold Aschenbrenner, just like worth basically also understanding kind of like the background of AI progress that plays into this. And then, yeah, like last of all, like if you just want to go to our platform, you can just find it on like app.primeintellect.ai. Get some free compute. I think you can just log in, and in billing, I think add this coupon, and then you can just spin up any GPU you want. Feel free to also join our Discord or ping me directly with any questions you have. And yeah, happy hacking on the hackathon, and looking forward to see all of your projects. Thanks for having me, everyone.
Thank you, Vincent. That was excellent. So I'll add a few words on how we're using Prime Intellect, or how we plan to use Prime Intellect, because there's a few cool things that they're doing. There's both their work on scientific foundational models. One of them that you could look up is called MetaGene1, which they collaborated with USC, the college, to create a specific model around monitoring wastewater for pandemic like outliers. Basically, the model can look at the DNA pairs in wastewater and see if there's any outliers related to like microbes and bacteria around pandemic. So that's like one super cool thing they're doing. And then more recently, as we started to look at different ways of scaling our agents, so the idea is like during the hackathon, we're trying to create one agent that is able to do discrete steps of knowledge work at a high caliber. But as soon as we have one agent able to do that, they're going to ask for 2, ask for 10. There's not really a threshold or a limit on how many agents would be effective in helping a research lab or a biotech firm or a BioDAO. And so we're looking at different distributed compute platforms. And so Prime Intellect has one that's called the Prime Intellect Protocol, where you can deliver a container running an agent, and that agent can be scaled in the cloud. So super interesting. Thank you, Vincent, for giving the presentation. And I'd like to introduce our next talk. It's also a virtual talk by a developer on the Eliza OS agent system. So this morning I spoke a bit about developing with Eliza. Now we'll hear directly from the team, and hopefully help everyone out there with some ideas and code help. So let me introduce Nisita from Eliza.
Hey everyone, welcome to Eliza OS workshop. I'm Nisita, and I'll be your guide as we dive into the world of Eliza OS, which is an innovative open source operating system built for speed, flexibility, and scalability. Most importantly, it's actually built to be yours. Now, who here loves creating things that push the boundaries of imagination? If that's you, you're in the right place. Today, we're going to explore how Eliza OS can become your go-to place for playing with and creating amazing things. Whether you're building something you've always dreamt of or just experimenting with a new idea, regardless of which it is, Eliza OS can help fuel your creativity. All right, so let's get started. So you might be wondering, like, what is Eliza OS? Well, that's a great question. So Eliza OS is a lightweight, modular, and fast operating system designed to make your AI agent development and bring your dreams to reality. It's open source, which means you can tweak it, modify it, and create your own unique solution that fits your requirements. And if you're wondering, well, why should I use Eliza OS versus all the other options that are available? Well, we're open source, which means this fundamentally allows a lot more progress and allows folks to be able to contribute, folks like yourself. In terms of customizability, it has customization at its core. You can curate your agent to have the personality and tone that fits your needs. And you can have this agent across various platforms maintaining that exact personality, which is kind of neat if you think about it. So think of it as your perfect foundation for your next big project. Whether you're building something for personal use or research project or something else, Eliza OS could be the place to get started. All right, so now we're actually moving to slide 2. A really quick disclaimer. the reason I give that is, so today being April 9th, 2025, a few of the things I might share may have evolved depending on if you're looking at this recording at some future date, partly because we're working on, continue to evolve the version that we have. So Eliza OS currently has an original version, which is the one you'll be using, as well as we have a beta version out currently. Naturally, you may be wondering, well, which one should I use? For the purpose of this hackathon, I'm recommending folks use the original version. You're going to be using GitHub documentation and following instructions there. If you're still curious about the beta version that's out and are keen to start using it, I'd still highly recommend using the original version at this stage, because beta, as the name suggests, is still work in progress, and we'd like to make sure that you're having a smooth experience. That's one of the primary reasons for suggesting to use the current version. And most of the plugins are yet to be migrated again as of April 9th. So the functionality that would be available to you is a bit more limited on the beta versus the original version. All right, cool. Now let's actually move on to, overview of Eliza OS. So I tend to think of it as, different components that make up the framework at a super high level view perspective. You'll want to think about, what type of agent personality and tone I'd like to give my agent, depending on my use case. And you'll probably also want to think about, well, how do I choose where I'd want to launch it? Again, it's all going to depend on the use case, because depending on what you're trying to do, maybe it's the right answer for you to run it locally, in which case you're okay to use a specific LLM and all of those details. Or if you're actually looking to have something like a social agent that is interacting with people, maybe you're going to end up choosing Discord as your platform, or some other Slack, or any of those things. Another one you're probably thinking through is, hey, what are all the different data sources and things that I could add to my RAG file? So that's another thing in terms of, what type of information do I want to provide my agent in terms of context? And the fourth one being, well, you want to choose your LLM, because that's kind of what makes the whole thing come together, is how I think of it. Again, I'm trying to maybe oversimplify here, so bear with me. So Eliza OS is compatible with most of the LLMs out there. So choose which one you want, depending on your own preference. And once you've chosen that, I'd suggest getting the appropriate API key and keeping it handy as you go through the next set of steps, because you'll need it. Another important thing to be mindful of is that we have lots of resources available. One other category is plugins, briefly touching on this, because think of this as all the different functionality that could be available to you, and by extension, your agent, because all these plugins are currently hosted in their appropriate GitHub repos by the folks that would have built them, and they are pointed to what's called a registry. This is the place you're going to go to. We'll share the link below. Basically, this registry will be your single source of truth in terms of finding all the different plugins that might be available and compatible with Eliza OS today. So keep an eye out for that. Okay, on to the next one. All right, so this is where we get a little bit nitty gritty. But even before we get a bit nitty gritty, first thing is, depending on where you're starting from. So let's say you are already a developer and know your way around, fantastic. This is probably likely like a 2-second skim through. But if you're someone who's maybe starting on a slightly on the beginner scale of things, this might be a few more steps. So we just want to cover this. Some of the key things that we want to make sure you're mindful of is to have Python. That's one of the prerequisites. Node.js, make sure you have 23 plus version, and PNPM, whichever code editor of your choice. Again, Cursor or Visual Studio, and there's many other options that are available. In fact, if you happen to be a Windows user, let's say, then you're actually going to need WSL2 as well, in addition to all the other ones up top. But if you're a Mac user, WSL is not required. Just make sure you have all the other ones. One of the hiccups I know I sometimes get caught in is I need to make sure that my node version is 23 plus. For some reason, I sometimes, my terminal switches that over, and all of a sudden I start seeing errors, and I'm just like, what's going on? Usually, I think making sure that I'm on the right version, helps kind of move things along and, smoother journey. There are also some really wonderful tutorials that I've really enjoyed, and I know a lot of the community and like other builders enjoy them as well. And I often use that because, they tend to be quite beginner friendly. Again, depending on where you're starting. So what I'd say is check out the Eliza OS developer YouTube channel. We also have a how-to playlist with some of my favorites, honestly. So do take a look at that and check that out. We also have a Windows setup tutorial for Windows users for the WSL component. So want to make sure that you're all taken care of. All right, now that we've got the prerequisites covered, let's move on to more fun things. All right, so you're probably wondering, actually, on the right-hand side here, there's some of the tutorials that will walk you through step-by-step, which will make your life a lot easier, I think, in my experience anyways. Okay, so super high level. You're thinking, okay, well, how do I start this? So to start building on Eliza OS, the first thing you'll want to do is clone Eliza OS. So please go to the GitHub repo, Eliza OS GitHub repo, which will have these steps, including these commands here. I've just highlighted a few here, but depending on, how your path kind of progresses, like that will be your go-to for making sure you're using the initial version of Eliza OS. All right, so item 1 that I want to call out once you have cloned Eliza OS and have it running is, well, before you start running, is you want to make sure you set up your environment variables. This is the LLM part from the original, from one of the previous slides we talked about. So let's say I chose Anthropic, then I need to set up my .env file with the appropriate key. One trick I also use sometimes is I have 2 separate API keys for 2 different types of LLMs. This way, at least my thinking is, one of them is my backup, just in case I, for whatever reasons. One fun thing I've noticed is, regardless of the order sometimes, if I have OpenAI and Anthropic, I have seen that it does have a preference for Anthropic over the other, but that's just a detail. All right, so you set up your .env file, which will get the LLM component taken care of. Now, what I call item number 2, which is the more exciting part to me personally, this is where you customize your agent character, personality, and tone. You can do this by tweaking your .character file, and providing examples is one really good way I find that you can really curate the agent to hit the right tone and pattern, that sort of stuff. So I generally really like providing speech patterns or like examples if there's a specific type of humor I want to fold into that. The world is truly your oyster in how you choose to curate your perfect character for this agent. Okay, awesome. Next step is, well, there's lots of resources like I suggested. So one of the first ones is we do have a dedicated builders chat for Telegram and Discord, because as you go along, you'll want to have, you're going to need technical support, or maybe you just want to talk to someone about onboarding. This is a really good resource to kind of keep on your radar and make sure you can leverage that. Because we don't want you to feel like you're alone in this journey. You can definitely, there's lots of us and there's lots of folks in the community and builders. So please do use that. Another resource I think would be really helpful for people to be aware of is the event calendar. So this is a public-facing Google Calendar that has a list of all the different events that are happening at any time of the day in any time zone. So that could be like an AI Agent Dev School if that's happening, or if it's just a builder demo that we're showcasing. This is more just to get a better sense of what is Eliza OS and how, like, what are all the really cool things that are happening. Maybe some of these will pique your interest and maybe you'll decide to join one of them. This is also a really great way, I find, to meeting others that might be on the same journey as you. And in some ways, like, you get to exchange some notes or, it's just fun. So event calendar, whether, some of these are virtual, some of these are IRL, but at least the really cool thing is you could just overlay this onto your own existing calendar. And that's the part I personally really enjoy, because then on any given day, let's say I decide, oh, actually, I have extra time. I wonder if there's any events that are happening. I could just look it up, which simplifies a lot of, having to figure out, well, is there something there? Like, when might it be? Oh, is it past? All of that. So this all removes it. So event calendar, to keep an eye on that. The QR code here, if you scan it, it'll take you to the link there. So please do take a look at that. And this is the builder demos and tutorials YouTube that I mentioned a couple of times. So this is a good place to get a sense of what types of plugin tutorials are available currently and what type of agents have been built. So there's some demos and there's some tutorials that are already there, but this is an ongoing or constantly evolving channel. So those will continue to evolve. We also, as we come across how-to videos that folks build out that we find are very helpful, we like to pin them there. So then they're all in that playlist. So then for anybody else starting new, you don't have to go through, several of them to figure out which ones have been helpful. So this is at least just a starting point. So please do take a look at that. Again, the QR code here allows you to go directly to that YouTube channel, and feel free to explore. I also find it kind of helpful for inspiration sometimes, just to get a sense of like what's available, what's not. So this is a good starting point as well. And this is a general overview of the ecosystem. There's lots of different plugins from a lot of different teams. Some of these you'll probably recognize, and there's lots of other folks that we're actively working with from like an Eliza OS standpoint. So just to give you an overview of this. Amazing. So again, if you didn't get a chance to join that Telegram group, please do. It is a dedicated place we have set up, especially for folks that are doing lots of different hackathons around, because we want to make sure you're getting the support that you need. Okay, perfect. We'll try to make sure that we are providing all the links that I've shared and kind of walked through today. We'll also share them in the Bio Teams Discord, so it's also accessible there. These are all definitely accessible in the Telegram chat that this QR code directs you to, so please do take a look at it. That's all I have for now. It's time to start building, and we're super excited to see what beautiful things you folks really bring to life over the period of this hackathon. Thank you.
Thank you, Nisita, and the Eliza OS team. Really appreciative of the support, both in the around getting the word out, and also the ongoing support in the Discord and Telegram for hackers in the BioAgents AI Hackathon. Were there any, I'll take a moment to ask if anyone here had any questions, any ideas around working with Eliza. Just give a moment for that. But, yes, let me.
So I want to understand. So what I understood is basically the runtime is very important. That's the core part of Eliza OS. So is it important to have a different runtime for different projects, or one runtime can be used for multiple projects? So projects are very different from each other. And I want to use Eliza OS for different projects.
Eliza OS is in a interesting point where they have a beta branch that has a lot of upgrades. That's a very actively developed beta branch, like a branch of the code base. In the hackathon, the BioAgent repo that we have, and then the plugin for the BioAgent are both based on that V2 beta branch. Nisita shared also how to work with the V1 branch. Because of the long-running nature of this hackathon, where basically if you fork our code, you'll be on this beta branch with additional features. But as she shared, there's a possibly simpler way to just use the main branch and fork that for agents. Did that answer your question?
I want to understand, like, let's assume I spin up a runtime. Can I use the same runtime for different projects? So projects like...
okay, yeah. Kind of, because the runtime that we've done for the BioAgents turns the default Eliza agent is more of it's meant for turn-based conversation, similar to like talking to ChatGPT. With our runtime, it turns it into more of like a 24/7 task runner, where it can respond over chat, but it's kind of has like an idle state, and if it's ever idle, it always has a next task to do, and so it's always running, which is quite different from the default agent, which is waiting for user input in order to perform the next action. So, yes, I think the runtimes, if you develop it, are shareable. You can but they do change the nature of the agent a lot. So.
And it will not affect the knowledge graph. So we want to build a knowledge graph for project specific. So it will not affect if I'll use same runtime for multiple projects.
Are you asking about the knowledge graph per project, or?
Yeah.
So if you if you clone the BioAgent plugin and start running it, it's going to look for a Google Drive with papers in it, and it's going to start to process those papers and add them to a knowledge graph. And so if you have a different Google Drive, it's going to create a different knowledge graph each time, or from different teams, depending on what's in that Google Drive. We'd like to see it improved with looking at different sources. There's archive, there's other sources for papers that you could pull from into the knowledge graph, and different ways to create the knowledge graph. But yeah, you're welcome. Any other questions? So I'd introduce the head of science at BioProtocol. James Sinka is here to talk about building scientific research collectives. Welcome, James.
Hello, hello. Let's see, is this mobile? I can do this. Yes? All right, looks good. All right. Well, thank you so much, everyone, for being here. Oh, no, I got to stay in one place? All right, thank you so much. Maybe I can just shift side to side. I'm the kind of person who likes to be active and engaging when I'm giving my talks, so maybe I can actually turn it over to you guys. So for the folks that are here, if you're a scientist first, primarily, could you raise your hand for me? All right. A couple, all right. What about if you're an AI engineer first and foremost? You work on the AI side of things, okay? So, and then what if you are a crypto person first and foremost? All right, so we have an interesting blend here. Okay, great. Well, as part of Bio, we are blending all three of these elements, right? Incredible breakthrough science, using AI to support these breakthrough scientific discoveries, and then crypto token economics to accelerate these breakthroughs into commercial potential and actually deliver real-world impact. Obviously, as you all know, we've railed on this point many, many times, but the time to accelerate science is now. And we've seen an incredible opening especially with the transition in this new administration, where the NSF and the NIH in the US have completely been gutted. A ton of capital has been cut from there. And so rather than waiting and expecting for someone to come save us as scientists, someone to help accelerate our science, it's our responsibility as scientists to save ourselves. Bio has already gone ahead and pioneered this approach. We've incubated a ton of BioDAOs. You should recognize a ton of the logos here. And we're even in the process of standing up a bunch more of these BioDAOs. In fact, Bio is the best place for anyone that wants to start a BioDAO, or as I like to explain it to scientists, they're on-chain research collectives. If you go to app.bio.xyz, on our Launchpad page, you can actually see a bunch of BioDAOs right now that are in the process of getting what we call curated, and that are pre-launch, that we're kind of teasing are going to come up soon. That's just the tip of the iceberg. We've got many, many, many more scientists and BioDAOs that we're working with. And today, I want to share with you guys a sneak peek of how we are using AI to make starting a DAO absolutely easier than ever. This internal AI DAO building tool we call the Portal. The Portal is basically an AI companion or guide that helps to bring any scientist, regardless of where they are in their scientific journey, to building a scientific research collective, and it guides them every single step of the way for what they have to do next. For the purpose of this talk, this breakdown, I've kind of explained a science research collective into 3 key parts. So the first is actually having scientific assets and progress that are posted on chain. That's the infrastructure that Molecule is building and Kevin talked about with the POIs. Next is actually using AI to help fill the gaps inside of papers and build out decentralized knowledge graphs, basically the home of each individual DAO or research collective. And then finally, I think the most important that often gets overlooked by newcomers, new scientists, is actually building a community spirit and movement as part of your research collective. Okay, I'm going to start with the science on-chain piece first. So as Kevin gave a great presentation earlier about POIs, or proof of invention, these POIs, as you know, can be as simple as you have an early stage idea, or you actually have data that's been collected from the lab, and you want to timestamp, you want to prove on-chain that you were the originator of this data. That's one example of a way a POI can be used, and that's sort of the follow-on, or I should say that's the seeds that eventually get turned into an IP NFT that can eventually be patented, monetized, sold, built through a joint development agreement, et cetera. But the dream here, the vision for the portal, is that it'll pull out even more nuanced scientific progress and help post it on-chain for you. So rather than having scientists need to go ahead and push buttons and learn how to send transactions to put relevant data on-chain, this agent that's going to sit inside of your Discord or wherever else your DAO is based will actually start to screen for the progress that's happening. So for example, you just finished running a lab run on mice. That data, it'll clean up for you and say, hey, we think this is an important snapshot, an important piece of progress in your scientific area. Would you like to post this as a POI? Would you like to put this on chain? And this serves 2 really key benefits. One is it allows the scientific process to happen in the open. I think academia has been very plagued with the idea of it's first to publish, and we want to make sure that we have a banger paper with a ton of citations. But that's counterproductive to what we think is the true heart of science, which is actually having your scientific procedures, processes available out in the open for people to check, to diligence, to give feedback on, and to move forward. And because you're the one who put that data on chain first, you still get the recognition of being the originator of that information. Rather than being the first to publish a scientific paper, you're the first to demonstrate this data on chain. That's one. And then the second piece is it allows the community to objectively see that this research collective is making progress. I think one of the big challenges that we've seen is communication of what research collectives are doing to get transferred outside of that Discord. If you're not a daily active user inside of that research collective, you might not know that things are happening, progress is being made. And so by streaming actively an agent pulling these data points out and putting them on chain, communicating them for you, the world gets to see that progress is happening, and progress and momentum beget more of that. And we think this will create a positive flywheel effect for DAOs and research collectives, attracting more and more scientists that want to contribute to these collectives. Okay, so that's research on chain. The second piece is scientific databases. So we've heard quite a number of times about decentralized knowledge graphs today. And this is the core scientific heartbeat of every single research project. Imagine a future where a scientist finds out about a DAO, call it VitaDAO. They're really interested in longevity. The moment they join VitaDAO through Discord, they get access to see what the collectivized papers that have been pulled together by all the cumulative researchers in VitaDAO are, and it creates basically a tech tree of understanding for where the cutting edge is. And then using AI, we can also fill in the gaps of understanding of what papers either may not have been contributed or opportunities for further investigation of research in that knowledge graph. Furthermore, and I think this is actually even more important, coming back to a question you mentioned earlier about Nobel Prize winning and attribution, using Origin Trail and an agent that can actually sit in and see who's posting which hypotheses, which ideas, which papers on Discord, we can attribute whose origination or where the origination came from for a novel insight that ended up getting put into an experiment, who collected the data from that experiment, who realized that there was a novel insight in here, and whoever ended up being the PI that published that claim. Every single person in that stack should get attribution and recognition for when inevitably a paper gets published or a Nobel Prize is awarded. You can see the provenance going back in time from where the original hypothesis was generated all the way through the data collection, so on and so forth. And that's the vision that we have here. And that is a more meritocratic way of making sure when people come in, when scientists want to contribute to a research collective, they get recognized for their efforts. Okay, this infrastructure will be built for new research collectives on day one. And then finally, the last piece, community spirit. As I mentioned, I think community spirit is actually, or community building is one of the biggest places where scientists have a blind spot. And I know that because I was a scientist that had this blind spot myself. It's very left brain versus right brain thinking, right? As a scientist, you think to yourself, well, the data should speak for itself, right? But the reality of it is people really love missions, they really love community, they love momentum, they love being a part of something that's important, and the data does not speak for itself. It's humans that have to advocate for this. And so one of the biggest pieces that we're working on as part of this portal is how to guide people through, how to guide founding teams through the process of communicating and building a movement around their research. So one very simple thing is how to set up a Discord properly to invite people to actually contribute to the conversation. For those of you that are tech first, that seems trivial. But for someone who's lived their entire lives in a wet lab pipetting, they don't know the first thing about Discord. Yeah, I see you laughing over there. That's exactly right. No, literally. Same thing here, like hosting Twitter spaces, town halls, journal clubs, so on and so forth. All of these seem trivial if you've seen this done before, but imagine this from a perspective of someone who's never built a research collective. We're making sure that they understand what the next steps are to make sure they build a community and not let the momentum here fizzle out. And we're envisioning this going all the way from the day one of setting up the Discord from the beginning, all the way through scientific road mapping and actually commercial pathfinding. So this guide can tell you, hey, look, we think that your research is really valuable. And you might ask it, okay, who in the public market of US and Europe biotech companies might be interested in this kind of R&D if it turns out the research pans out? Well, because of the state of LLMs right now, we can actually pull up a list of 10 companies who might be interested in actually co-developing or acquiring your IP. If you have that as a target, and by the way, that is something that in the past, only a few months is capable of being done, right, through deep research from OpenAI. In the past, you'd have to find someone who had experience in public biotech M&A deal making in order to collect that kind of research, but we're giving that as a power to research collectives from day one. There's a lot more I can say here, but this is just a bit of a sneak peek for you guys. And the final piece is here. Unfortunately, my slides are a little cut, but the portal agent is trained on all of our internal documentation. So we have been building BioDAOs now for actually 4 years, which is kind of crazy to think about. And so all of our innate knowledge and tribal information around what it takes to build a good scientific research collective has been put into documentation and trained. So that way you can ask it any kind of a question like, listen, how do I even understand if Web3 is right for me? Instead of trying to go through this entire process from the end and realizing, okay, actually, crypto is not the best way for me to accelerate my research, you can find out from the beginning by talking to our portal, by talking to our guide, and learning about what the right way to integrate Web3 might be, or how you can motivate people to actually contribute to your movement. A lot of DAOs when they first start out, they're like, oh yes, if I set up the right incentives, people will automatically contribute. But we're all humans. We all know that things don't work the way, in theory, they should. They don't work that way in practice. So this guy can help you answer a question of what should I do to continue to motivate folks to want to contribute. And it can do that with infinite patience and move you closer to success for building your scientific research collective. Now, this is not just a hypothesis. It's not just a theory. V1 is currently being built. If you want to see what the V1 or V0.1 of this project looks like, come talk to me. I'll give you a demo. I'll show you what it looks like to move scientists through or patients through the research collective building process to actually come up with a successful DAO at the end. And I encourage scientists and patients to apply if you want to start one of these on your own. You can go to bio.xyz/apply to learn more. And if you're interested in hacking or working on this at all, just come ahead and come and find me. I'll be walking around afterwards. But you can also email me in case you don't get a hold of me here at the conference for follow-up questions or any ideas you might have. Cool. Thank you so much.
And with that being said, we're actually going to quickly open it up for questions. Does anyone have anything that they want to ask James?
Right behind you, Eric.
Oh.
So thank you. That's very futuristic.
That's the goal, yep.
Yes, exactly. I'm thinking, is there any way or any plan to connect this AI to, for example, lab notebooks or something that is already ongoing? And even that, I think it's a very complicated topic for scientists, to have everything digitalized. So maybe you have something.
Yes, yes. So like you're saying, scientists have their own preferences. And so there's two schools of thought here. One is you force a top-down architecture and say all your information has to be put here. And then the other school of thought is we will meet you wherever you are. So if you happen to use Obsidian or Notion or Google Drive, whatever it is, or maybe Jupyter, we will find you where you are and we'll bring that data in. At this point, we are customer-centric, and so we're going to listen to our customers and see if there are patterns there in where they like to store their data. And we've seen a whole lot of different places that people like to put their information. So taking in customer feedback and then looking at what we can develop, we're essentially going to work into the middle of that. And I have a feeling that we'll have maybe 2 or 3 options that work for folks. That way, there's something for everyone. But at the end of the day, if it doesn't exist in a way that can be discovered or published, then it doesn't really matter to our thesis for open scientific research collectives. And so we're particularly looking to work with scientists and patients who value the open nature and recognize that having this be visible is better for their movement and will actually lead to success rather than the people who are sort of like safeguarding and afraid to kind of get scooped on their idea. This very much reminds me of sort of the Silicon Valley mindset of like, ideas are a dime a dozen, execution is everything. And so we're looking for scientists that have that same kind of a mindset. And so like you're saying, yes, there are some people who are gonna be sensitive about, oh, I don't wanna publish this, I don't wanna publish that. So we'll give them some versioning control, but if they're not comfortable having the majority of their research out in public, eventually, within a matter of weeks or months after the research gets done, then they're not a good fit to start a research collective, in our opinion.
Yeah. There might be the need to scan a lot of paper lab notebooks.
You mean like manually scan the written ones?
Yes.
Yeah.
I think that might be something.
I think tooling is good enough at this point that you can probably take a photo and hit upload, right? That's I hadn't thought about like actually written lab notebooks because when I was in university, yep. And then I know you would have sort of like the original page, the carbon copy, and then like the third, if you wanted a second copy that you can hand out to people, like if that would make it to an SOP or what have you. But that's a good point. So thank you for that one. Yeah, appreciate it.
All right. Does anyone else have questions for James?
I know that was a really ambitious thesis, and I covered a lot of ground today. So if you want to talk to me about this one-on-one, I'll also be around. But thank you so much for listening, guys. Appreciate it.
All righty. So as a conference organizer, I can say that this is the first time that I have ever been looking at finishing ahead of schedule. And that is beautiful in its own right. It's a very unique problem to have, but I first off want to start off by thanking everyone who's come in person, everyone who's listened on the live stream, the tech partners, the sponsors, the mentors, the judges, the incredible team who goes into putting on this event, and obviously, most importantly, the hackers. So for anyone who's actually coming in, we've given a lot of information over the course of the past 2 days, be it new technologies, new teams that you can work with, new ways of thinking about science, and even just new collaborations. We hope that all of this is useful for each and every one of you because there's a lot that can be taken out of this larger event. I want to quickly start to bring us to a close. So I'll be giving a quick presentation on some of the hackathon ideas that we would like to see. And then our platinum sponsor for the event, Solana, will be coming on in just a little bit to talk about how they see their integrations with DeSci. And then we'll close out with Sean in a nice 5-10 minute presentation and officially have the hackathon kicked off. So with that being said, I just quickly want to go through some of the ideas that I've had around this event and some of the ideas that our larger community has put together with what we want to see hackers working on. I do want to say the prize tracks are in a lot of ways kept generalized without specific detailed prize metrics because ultimately science itself is fluid. It's very hard to say what is better than another. So we assembled a panel of experts to handle that for us. But as we go through, the panel of experts, whenever we put them together, these 12 judges, we asked them for the projects that they would want to see, that they thought would make a difference in the world. Also asked quite a few of the DAOs and community members who are out here building what they would want to see. So I'm going to quickly just go through some of what the hackathon ideas are. So for anyone who's curious, this QR code will take you to the ai-docs.bio.xyz site, which has a full listing of hackathon ideas, but also includes a lot more information on the event, everything from how to set up an Eliza repo to who the judges are, and much, much further. So if you have any questions that aren't on the docs, as always, Discord is the best place to ask. That's where the event is going to be primarily hosted, and we'll have a QR code link for the Discord at the end of this. But with that being said, I want to just quickly talk about a couple different hackathon ideas. So the first one that I'll talk about, since we've already covered VitaDAO and Cerebrum DAO in presentations yesterday, the first one I want to talk about is the SpineDAO Chronos project. And essentially, SpineDAO is a group of researchers, very impressive researchers. If you get the chance to look into some of their publications, their background, these are people with 40+ years of experience each, probably 100 cumulative years of experience in spine surgery and academia and in quite a few different areas of that specific kind of medicine. And what they want to do as a part of the initial stand-up of SpineDAO, which, by the way, is going through curation right now at the moment, as James mentioned, is to represent and revisit overlooked historical and traditional spine medical insights within a background of modern knowledge. So I had the pleasure of talking to Vincent, the founder of SpineDAO, the other day, and he's actually working with a couple different archives in France at the moment to get larger historical collectives of information, scan them, digitize them, and see what actually comes out of it. So as he's doing a lot of that background work, and as him and his team have worked to put together a larger collection of information on what they think is relevant for SpineDAO, using that as a basis for hacking and for mining is something that we would love to see hackers work on. Because not only does it bring new ideas into the world, it also would really help accelerate a very promising early stage BioDAO and allow them to focus their time, their money, their capital on the things that really immediately matter. Some of these overlooked historical insights can be very difficult to get funding for in the current system. The next hackathon idea that I want to talk about goes a little bit to one of the questions that was actually asked in the previous talk. and it's the idea of an iterative publishing stack. So one of the coolest things about working in decentralized science is that we have different capital flows, which means that we can form different incentive structures. In the way that science is currently run today, this has been a recurring theme throughout the talk and quite frankly throughout the entire history of decentralized science. You have someone who has an idea. They take a year to get funding, then they take 3 to 4 years to actually put an experiment together, and then they take 1 to 2 years to publish. So what's actually being seen in the published literature is often half a decade behind what's actually happening in the real world. There's little to no visibility. And it's funny because whenever you tell this to developers in the decentralized web, they're like, well, why don't they just use GitHub? And it's a very good question, because the Git primitive is something that is incredibly powerful, but ultimately there is a lot of momentum behind current incentive structures. And I won't go too far into that, but we have the ability to redefine the way that publishing happens in academia thanks to new capital flows. So one of the things that we really want to work towards in terms of putting science on chain is the idea of an iterative publication stack based on POIs, based on IPTs, where it's not just the final manuscript, but it's the lab notebook, it's the data, it's videos of someone actually performing the experiment which play into the method further and further along. All of these things are different components of proof of invention. So anyone who's looking to build a tool like that would be a great track for the hackathon, which I think we as a team would be very interested in seeing used. Another hackathon idea that we have, which I think is really prevalent, is the complexity slider idea that Barend mentioned. Now, I want to go ahead and say this is a very difficult track. This one is a little bit out there, but for anyone who can make this happen, this would be absolutely incredible for the world. So a lot of Barend's ideas are based on something called percolation theory, and I'll let you look into that of your own accord. But one of his former grad students, who's now been a colleague of his for the better part of 20 years, did his PhD in chaos theory with Stephen Wolfram, and firmly believes that the way that you structure knowledge graphs as a base piece of information to then query information off of has a lot to do with the results that you're going to get. And that there are optimal structures for subgroupings of knowledge graphs where as you start to add information connections between different clusters, eventually clusters just merge into one. And there is a point called the percolation point where we have the optimal subgrouping of fields needed to find connection and information. Making a knowledge graph is more of a science than an art, but a lot of the, according to Eric, a lot of the mathematics behind percolation theory can turn this into a sharp, pointed graph once you've actually set it up correctly. So really curious to see if anyone can push this forward. Do want to continue to emphasize the point that's been brought up several times throughout this hackathon. LLMs, while incredibly powerful, do not have grounding in real-world knowledge. As we're working towards building knowledge graphs for these BioDAOs, we have to keep in mind the fact that there is a real-world model which is needed behind each and every single one of these pieces of technology. Then the final hackathon idea, and this is one that actually came from me personally, which I would really just love to see. It also came in conjunction with some conversations that I've had with Slava, another one of the judges, is the idea of utilizing knowledge graphs for the detection of potential null results. So this idea came in a large part from my engineering degree, actually, where, I hate to say it, but the best professors were the ones who would give you all of the equations in Cartesian on an XY graph. And then the moment that you got to the test, all of a sudden the question was in polar. And if you had just gone through and done the rote work on the problems itself, oftentimes you were going to get that polar problem wrong. But if you took the time and the effort to understand the concepts underpinning the actual problem, the meaning behind the equations, converting it to polar actually wasn't that hard. So one of the things that I believe, personally, which is possible, which would have a large impact on the world as we see it today, is utilizing knowledge graphs to detect null results. So there are subtle contextual clues in any given manuscript. As we start thinking about the creation of hypotheses, a lot of LLMs will likely come to the same conclusion when prompted with similar information, at least in the aggregate. So if we see an LLM that's been trained on information from, let's say, 2010 to 2015 in a very specific field of research, and then we ask that LLM, what are the hypotheses that should be tested in 2016? The hope is that that LLM would get those questions right for 2016. It would predict 75% of the papers that were actually published, but that there would be a very small subset of manuscripts which were not published in 2016. But every single LLM agreed that there's a hypothesis here. There's something that we should be looking for. While once again, this is a difficult problem, I don't think it's outside of the realm of possible given the information that we have today. I would encourage people to look at some of Slava's presentations on specifically the Hotel California slides. To me, those were some of the most important in what he was putting out there, because it talks to a certain extent about disambiguation and how that happens differently between knowledge graphs and embeddings. I guess embeddings don't necessarily have disambiguation, but that's beside the point. And try to use some of those concepts to work towards a better result on this project. Once again, this one is definitely a little out there, but I do think that it's within the realm of possible and cannot express how excited I would be if someone could do that. So with that being said, do want to just quickly start to move this towards a close. It's been 2 long days of presentations. I hope everyone has enjoyed it. I hope everyone has got something meaningful out of it. The conversations will be happening on the Discord. So for anyone who wants to join, there's a QR code, there's the bio invite link. There is a team recruitment channel, or I think project recruitment is what it's called. As you have ideas, as you form things from watching these 2 days of presentations, go on there and talk. Go ask for support, go ask for hackers. And to a certain extent, this is a call to a lot of the scientists out there, because you have the ideas. You understand the problems in science and what would need to be solved. You understand what's possible. You've probably seen it happening in your specific field. And to all of the developers out there, would encourage you to go back and look at a lot of the tech partner talks. So all of the origin trails, all of the coordination networks, all of the Eliza OS talks, in addition to everything that Slava put out in his more technical presentation. Hopefully all of that's meaningful for you and can help you contribute to a team in a much faster and more efficient way. Now, with that being said, I do just want to say once again, thank you to everyone for joining. We're excited to have you. And our last talk for the day is going to be from our Platinum sponsor, a group who's done a lot to make this event possible. I'm happy and pleased to announce Jerry Lee from Solana. Take it away, Jerry.
Hey, how's it going, everyone? Is my sound coming through okay? I'm gonna assume yes, so we'll begin. Thank you, Eric, for the very warm welcome. We're incredibly honored to be partnering with BioProtocol and sponsoring this hackathon. I think DeSci is at a very interesting inflection point where some of the more macro conditions make it very compelling to fund a lot of these scientific efforts that are not getting funding otherwise. With that being said, we'd love to kick off my short presentation. It won't be as in-depth or as technical as some of the other ones I've seen yesterday. Great presentations. But wanted to introduce a little bit more about Solana at a high level, and then talk about our focus in DeSci, and then at the end, introduce some more resources around specifically building AI agents on Solana, which is the focus for this hackathon. Awesome. We'll proceed to the next slide. I'm on slide 3. I'm not sure if... Oh, wait, 1 second. Hold on.
Hey, Jerry.
Here you go.
Can you hear me?
Yeah.
So
I
we
decided
can't
to
see
go
your
up now.
slides at the moment. Alrighty, the slides are coming up. Yeah, there we go. We see them, and you are presenting correctly. Would you mind starting from the beginning so that we
Yeah.
can get the proper YouTube cut?
For sure. Thank you for having me. Thank you, Eric, for the very warm welcome. We're incredibly honored to be platinum sponsors for the Bioprotocol Hackathon. I think the DeSci mission and ethos is very near and dear to your heart. And at Solana, we're always looking for very sustainable, meaningful impact driven by Web3 and crypto models. And so, just in the backdrop of what's going on in the broader macro context, I think it's now more important than ever to be funding a lot of these scientific efforts that are being overshadowed by a lot of the drama going on politically in the world. With all that being said, at a high level, wanted to share a little bit more from Solana, our focus on DeSci, and then tactically some of the resources that my colleague Jonas will introduce to talk a little bit more about building AI agents on Solana. And so at a high level, where is Solana today? Solana is the world's most used blockchain. You can see on the upper right corner in that graph, Solana processes more transactions than any other blockchain combined on any given day. By orders of magnitude, Solana is the green neon line you see up there. Interestingly, you also see daily active addresses, and this is kind of akin to user counts or fee payers using the blockchain. And although we're also leading in this metric, it's worth noting that we're not ahead by orders of magnitude compared to what we see in daily transactions. And that what really tells us is not only is it easy to use Solana, and there are a lot of users using it, users use it more often than any other blockchain. And so if I'm a single given user, I might use it 10 or 20 times per day because of some of the user experience advantages we'll touch on later on. But what this means for AI agents, which is the focus for this hackathon, is that previously we got a lot of maybe flag that Solana is a bots-driven chain, but in the new paradigm of AI agents, I think that's not really necessarily a bad thing. When you make it easy to transact on a blockchain, you can expect people to do more transactions relatively to other chains. Some of what makes this possible, one really unique aspect of Solana is what we call local fee markets. And so what this means is in traditional blockchains, sometimes when you're competing for the same block space, if there is a lot of activity driven by one particular project or some interesting opportunity, then fees go up. Gas and transaction fees scale because of this one thing affecting the entire market for fees. But in Solana, where you have local fee markets on the right side, even if there is a really interesting or hot DeFi arbitrage opportunity in one lane, and then a really popular NFT mint in another lane, if you're not competing for that same specific state, then your fee experience remains unchanged, and their users should not have their day-to-day impacted. And so all of this is super cool. And Solana, I could go all day talking about the really great things Solana has done. But what Solana probably is most known for is probably late December, early January, when meme coin mania was really taking over. And so you probably saw a lot of headlines around, Doge with, Farcoin, lots of other really interestingly named meme coins. And then to top it off, there is the Trump meme coin in January. And so that is kind of like what really drew a lot of retail to onboard onto Solana. I think there was a metric that week over week there were 500,000 new retail users being added to the blockchain, simply via meme coins. You'll see a little more of the headlines touch on this in the bottom, but I think behind this, right, like past the simple notion that Solana is the meme coin chain, Meme coins happened organically on Solana for a certain reason, because the user experience was there, right? Like the onboarding via Phantom, the low gas fees, the fast finality speed, all these things combined for a user experience that made it very easy for meme coins to catch fire on Solana. But I think the really important piece to understand is, meme coins demonstrated this original notion of crypto financing, being able to attract a lot of attention and mind share, and somehow galvanizing that into capital, into liquidity, to pump some token into the stratosphere. But I think what encapsulates our vision is actually what Vitalik wrote in his essay, "What else could meme coins be?" And so society always needs to fund large-scale projects. Markets and institutions are the main ways we do that today. And in some cases they work and they fail in others. And so, our ethos for DeSci is, what if we could use the attention, the capital and the liquidity that we've seen meme coins being able to attract, but direct that towards more meaningful impact and towards more sustainable causes. And so if we think about all the different ways that Solana has been successful in attracting retail users and user adoption and kind of the liquidity moat that we've built, I think our mission at Solana Foundation is to drive that towards the use cases where people don't leave Solana with a bad taste in their mouth, where they're able to get behind impactful causes. And so that leads us to DeSci. And so these are some of the pretty tactical pain points that you see in TradSci, and that DeSci has shown initial promises of solving. All this combined, right, again, with the backdrop of university labs not getting funding or having their grants frozen, with the backdrop of only 10% of drug development efforts actually making it to mass markets. I think we've seen a very inefficient traditional drug development process, and things are getting harder and not easier. I think this is a more ideal time, more than ever, to find out the ways that the DeSci model can lead to better outcomes for drug development, better outcomes for health as well. And so we have a renewed focus on DeSci. We're going very hard into this vertical to demonstrate that Solana is open for business for DeSci. Two big events and initiatives we have coming up, both in New York. So if you're in the local area, heavily encourage you guys to check this out. On April 22nd, we'll be hosting the DeSci New York City community at Skyline. Skyline is the name for our New York City office in Lower Manhattan. This is a long-standing DeSci community that hosts a wonderful speaker series, and we're using this as a warm-up event to lead to Accelerate. So on May 20th, right, as a side event to our Accelerate conference, Accelerate for Solana is a conference focused on highlighting crypto innovation in America. And so we will have speakers from New York with 3 stages. The New York stage, which is all about finance and DeFi. The San Francisco stage about tech and products. And then the DC stage about policymaking. And so all these really combine to showcase how the US is putting crypto first. As a side event to that conference, we have the DeSci Science Fair. And so this is an all-day DeSci event showcasing some of the really cool DeSci projects building in Solana. We'll be assisted by our wonderful friends at BioProtocol, along with some other cool projects spanning, BioDAOs, smart wearables, prediction markets, all the cool ways that Web3 is really innovating in science. To leave you guys with kind of a more tactical call to action, this is a resource where you'll find Jonas, who will give a brief overview shortly, giving a walkthrough on how to build AI agents on Solana.
Hello, everybody. Can you hear me? I think so, right? Jerry?
Yeah, I hear you. I think we're good.
Okay, cool. So yeah, I'm Jonas, also working for the Solana Foundation. I do developer relations. And yeah, since this is AI related, so we have a few resources that you can try out. If you scan this QR code here, you're gonna be forwarded to a guide that we wrote, which shows you like all the different things that have already been built for Solana using AI. So we have like integrations with large language models. And yeah, these can be combined with other things. So there's a thing called AI frameworks. There's, for example, Eliza. And what this one does, it takes an LLM, so large language model, but it combines it together with like some actions that can be performed on the Solana blockchain and also other things. And also it combines it together with a database that can basically have memory. So one of the examples we have in this AI guide is just a chatbot where you can talk to, and it can, for example, mint your tokens, it can swap tokens, it can create NFTs and all kinds of things. And these actions are actually coming from a thing called the Solana Agent Kit. So how this works is this kit basically provides a bunch of functionality. And then the LLM is able to call these functionalities and then save the current state in a database. And like this, you can build all kinds of cool things. So with Eliza, for example, what you can build is you can build a Twitter bot, which is like tweeting something every few hours. And then whenever someone replies, it mints a token for him or something like this. So you can also, yeah, you can build all kinds of things with this. So hopefully you can like combine some AI agents with DeSci somehow. So yeah, I'm very excited about what you're going to build, and I'm joined in the Telegram group. I'm going to share a few resources there, and I'm happy to support you with everything that you need. There's also like some on-chain programs that you could write, but you don't necessarily need to write your own programs if you want to do something on Solana. You can just interact with many different APIs. You can just use JavaScript. There's a nice example in this AI guide as well, which is an agent which is able to purchase Amazon stuff for you. So there's yeah, all kinds of possibilities. I'm very excited about see what you're going to build and happy to support you there. So yeah, I'm in the Discord under Jonas Hahn, and I just joined the Telegram group as well. So yeah, let me know what you're building, and yeah, very excited to see what you're going to build. I think that's it from my side. Jerry, do you want to have a few words still, or otherwise I would just say let's go build.
That's it from my side too. Thank you for leaving it off on a very inspirational note. So please go check out the resource. The QR code is on that deck. And in addition, should questions come up, please tag us in the Discord. We're really excited to see what you guys build on Solana, and there's a ton of resourcing. So if you need anything, please let us know.
Yeah, and we also have an MCP server. So if you're like coding with AI, like in Cursor, for example, you can just use this MPC server, and it will be very helpful in programming anything on Solana. So it like checks all the docs and all the questions that have been asked before. So that one's very helpful. I'm gonna put all the links in the Telegram group now. So very nice meeting you all. Good luck.
Thank you all.
Thank you very much, guys. I will ask the group here for any questions while they're still on the call. Yeah, we have one from James.
Oh, we can't hear you. So if you could like repeat it in the microphone, maybe.
Hey, can you guys hear me?
Yes.
Yes. All right. Awesome. Are there any applications that you guys are particularly excited to see get built, or that you think Solana is particularly unique as an infrastructure architecture to be built as part of this hackathon?
Yeah, I could take this one. One really cool thing is, I think, in one of the prompts or recommendations would be a decentralized knowledge graph. I think one really cool thing about Solana is its composability. And so the ethos behind Solana is everything's single shared states, and people are writing to the same database or blockchain and updating as we go. We call this a multiplayer experience. And so being able to have this one kind of graph where a bunch of AI agents can autonomously update and reference will be really exciting for us, and a great kind of start to the infra on DeSci. I'm not really sure what use cases this could spawn, but another really unique thing about Solana is what we call compressed NFTs. And so in essence, it's a fraction of the cost to mint NFTs here, as would be on comparative blockchains. And we've seen many projects not outside of DeSci take advantage of this by shifting to more of an abundance mindset. So previously in blockchain, like, you're constantly constrained by I'm not going to mint this, or these assets will cost too much to transact because of the transaction fees, because of the high mint costs. But if you kind of threw that out the window and costs were no longer a thing, what kind of new engagement models would you be able to spawn because you're able to just mint NFTs for the hell of it, or have users generate their own NFTs, or in this case, AI agents generate their own NFTs as well. And so I think I'm really excited to see something cool come out of the fact that you could just mint a lot of these things at minimal costs.
Cool. And as a follow-up, could you give us an example of what one of those projects are that uses the compressed NFT architecture, so we can use it as a source of inspiration?
Yeah, I'm happy to share more resources. I'd say, like, a lot of projects on Solana are using compressed NFTs. One of the most most famous ones would probably be I say Drip House. This is a consumer product platform, basically a collectibles platform, and so people can collect these NFTs at no cost. And many projects go on to Drip as a way to reach a new audience, to collect IP, to collect art, etc. And so because they can collect this for essentially no cost, it's a really cool distribution channel, and products are able to see what wallets have collected their free NFT, and then introduce a call to action that gives this wallet something of value in their actual game or in their actual app. And we've seen like really high conversion rates using Drip House as a top of funnel UA, user acquisition platform, to bring people from Drip into your native app, your native project. And when they come here, right, it feels like a warm hug because you've given them something of value that doesn't necessarily cost anything, right? But it's worth something in whatever experience you've created.
All right, guys, I think that's all the questions. So again, one more round of applause for the Solana team. Thank you.
Thank you all.
And we really appreciate the Solana support. I'd love to see hackers build more connections to like on-chain science. I'll talk about it a little bit more in the closing, but the idea of attestations, like on-chain knowledge graphs, all of that could be is in scope for the hackathon. We are at the end of the day. I have just a short some notes I want to bring up and wrap this up. So what I want to go over is all the different speakers we had, and we're really, when you talk about agentic science, it's a nexus of all these different disciplines. And I'll just kind of talk about the speakers and what these disciplines are. And we started yesterday with meta-science, which is the science of studying science. And there's a really interesting field and research on how to better accelerate how people go through the scientific method. And we had Dr. Barend Mons and Slava speak about knowledge graphs and the optimal prompting for them and what the output of AI, what should we be directing it for, and how to advance ideas that are the right, there's a spectrum between obvious ideas and sci-fi ideas, and we're aiming for that sweet spot right ahead of our knowledge, and it's a very challenging problem, but Dr. Barend Mons calls it the percolation theory, and it's a good mental model for how we can be prompting the AIs to not give us super obvious ideas, but not give us super sci-fi ideas that are impossible to test for. Next, we just have the entire field of biotech and biomedical and the biosciences where we want to focus the AIs to be able to contribute and learn in these fields and contribute to the discrete steps of knowledge work. We had presentations about AI, Vincent from Prime Intellect, we had Martin from Coordination Network, the Eliza team, and then on the in post-production, we're going to add the speech, the talk from Jay from BRD, which they have a really interesting multi-swarm system, multi-agent swarm system for generating hypotheses and grading them. I want to stress that all of this is also, basically there's a field of Web 2 agents, like Web 2 scientific agents, and they're missing the complete on-chain side of it. And so if you don't have on-chain science, you're missing decentralized knowledge graphs, you're missing attestations, you're missing the idea of pre-registering what you're studying for and making it more reproducible, and you're missing publishing data on-chain and like timestamping it, and all of that is one of the reasons why we built on Eliza, because they have access to a wallet, not so much for transferring tokens, but just for signing attestations, and signing with a public key pair is a very effective tool for an agent to have. And so we're trying to show that on-chain science and on-chain agentic science is strictly better than purely agentic science without having a public-private key pair attached to a wallet or attached to an agent. So all of that combines into what we call BioAgents, and the point of the hackathon and why we were open sourcing them and kind of kickstarting this open source community for them is that we know we're 1% into how effective these agents can be. Like, we're 0.1%. Like, we're just getting started. There's all these different fields that they can advance in, the ones I mentioned. Like, every person with idea, it's probably never been tried before. And if you combine one or two of the companies that presented today with the BioAgent repo, you're already doing something that no one in the world has done. And so it's really cool. These bioagents need better, like, instant access to contemporary papers. They need we need to create knowledge graphs over every domain of science. We need to give them the tools to interact with the world, connect to Web 2 scientific APIs. There's many backend services written in Python that the agents could interface with, and that's basically easy hackathon ideas. And the mission of the hackathon is to, over the next 2 months, to collaborate with us and share what you're building, and really invite, we have a lot of crypto people in the hackathon, we have some AI developers on Eliza, and we really want to invite more people in the biosciences to learn about what we're doing, tell a friend, tell them there's this cool new thing, how agents can interact with their scientific data sources, and invite them to join your team, collaborate. This is a long-running hackathon, so if you're watching this in days or weeks, there's still time to join. And I want to stress that we're keeping everything open source, because it means that these agents that we create, and everyone creates in the hackathon, you can run them at home, locally. A company can run multiple agents in the cloud server, but the cool thing about blockchain is that we can create a globally distributed and basically a citizen science fleet of agents that are able to it's a larger fleet of agents than any one company or any one person can create on their own. And when we create this large fleet of agents, it's going to be instrumental in the coming months and years to accelerate. It's almost like having a supercomputer or having the Hubble Space Telescope, where we can have a BioDAO like VitaDAO, which has these very specific problems, which if you had one agent, it would take months or years for it to run through all these tasks. But by having 10,000 agents, by having millions of agents, we can accelerate the process and accelerate science. And the key piece of why BioProtocol is doing this and wanting to build it is that this giant fleet of agents would not be possible without the globally distributed on-chain funding. And so when we have this giant fleet of agents able to accelerate science, it's almost like a sci-fi idea where we just take crypto, we take the blockchain, tokens on the blockchain, we give them to the agents to pay for their compute, and the end result of that process is science. And so we're happy that the BioProtocol and BioToken is going to be powering this, and we're excited to see where it goes. So I think that's it. I'm going to wrap up with this. The final things for the live stream, join the Discord if you haven't yet, and that's where all the communication around the hackathon is going to be. It's been linked multiple times today, and it's on the website ai.bio.xyz. To everyone here in person, this wraps up the event. You don't have to leave yet, but we are happy to chat, and thank you all for attending, and thank you all for watching the live stream. That's all.